Track B session under the theme Multimodal AI will begin at 1:30 p.m. Please make your way inside and take your seats. We would also appreciate if you could switch your mobile phones to silent mode or vibrate. Thank you. 멀티모달 AI 세션은 오후 1시 30분에 시작될 예정입니다. 안으로 들어오셔서 자리에 앉아주시기 바랍니다. 휴대전화는 무음 모드나 진동으로 전환해 주시면 감사하겠습니다.
Sure, yeah.
The Track B session, Multimodal AI, will begin in a minute, so please make your way inside and take your seats. We would also appreciate if you could switch your mobile phones to silent mode or vibrate. Thank you.
No. Yeah. Yeah. Yeah, I can. Yeah.
afternoon, everyone. My name is Changhee Lee from Korea University, and it's my pleasure to serve as a chair of Track B. Welcome to this session on multimodal AI. Today, we are pleased to welcome leading researchers and industry experts who will share their latest research and insights into multimodal AI, exploring how AI models integrate and reason across diverse data modalities. I hope today's session will provide valuable insights and inspire meaningful discussion. Please also note that this session is being live streamed on the official YouTube channel of the Global AI Frontiers Symposium 2026. Now, let's begin with our first presentation. Please join me in welcoming Mengye, professor at New York University. He will deliver a presentation titled The Always Learning Machine. Please give him a warm round of applause.
Thanks for the introduction. Thanks for having me here. It's very excited to give this talk. So let me begin by tell you about the two potential paradigms of AI. I mean, one is already pretty much realized. I call it the freighter paradigm, where you build a tens of thousands tons of cargo ship, and this is the model, and you put all kinds of data as containers on the ship. Okay, so the data come from the internet, comes from human demonstrations, come from engineering, all kinds of post-training tasks and rewards, and then keep refining it so that it contains everything that we can possibly ship in a container. Okay, so we have seen a lot of success with this paradigm, but there could be another potential alternative, which I call it the sailor. The sailor isn't nearly as big as the freighter, but it allows you to sail to anywhere in the open sea. Okay, so you will grab resources as you need, visiting different islands, and even potentially build your own sail and your own deck using the resource you can get. Okay, so the second type is more of a kind of aspiration that inspires our research more than it's something that's already realized. And we have no idea right now how to realize it, right? So, the freighter is our today's big frontier AI models, and the sailor is the always learning machine that I'd like to share today. So if you imagine today, if you build an AI agent, what does it like to be living from its own world, from its own experience? Imagine that you wake up, today is 10 years later, 2036, okay? And you wake up, you're a helpful AI agent, and this is what happened a week ago, this is what happened yesterday, and what would you like to do next, right? It doesn't feel very real in this AI agent. The memories are all scattered in your pre-training knowledge, and you're given just a little bit of a context, what just happened. So essentially, there's no up-to-date perception of the new world, and there's no continuous episodic memory. Okay? And this is just one little piece why it doesn't feel like a real experience from today's AI models. And imagine what learning looks like in a real-world embodied agent. Okay? So you'll have to quickly adapt to new environments and learn in the open world. You encounter new concepts, new tasks, and new goals. You take actions and learn from these new observations. And essentially, your memory form new representations of perceiving the world. These representations change as you do the exploration. So you might be wondering, okay, why can't we just learn everything in a big static AI model, right? So I think this is a great question to wonder about. And Rich Sutton has, put out this big world hypothesis, right? Which is essentially saying that the AI models that we build, the AI agents, can never fully perceive model or learn the optimal solution to the entire world. The world is big, it's dynamic, and you really have to have an AI agent that's domain general, that's experiential, and that's open-ended. Okay? So instead of put all possible offline data and pack it into this freighter ship, okay? In contrast, the always learning agents just have to learn the current tasks very well. Okay, so this is what I'm going to talk about today, the always learning machine for embodied AI. And the existing paradigm also trains AIs or potentially embodied AIs, but they train from all kinds of internet data with stage-wise pre-training. You model, say, perception stages, planning stages separately, and you do a lot of offline pre-training and human demonstrations. And instead, the always learning machine will learn the representation in a closed loop. It will do the perception and then transfer them into memory with high-level abstractions, and then do the planning, and then take actions from your plans. The actions will lead to new explorations, which leads to new observations that forms your new representations. So everything is performing perception and action in a closed loop, and then also learning the representation from there. And you might also wonder, why not doing reinforcement learning? What about RL? Where's RL in this picture? Okay? So similarly, RL also performs learning in an agentic environment. But what's different is that RL deals with the classic ones, only deal with the exogenous objectives, which is, for example, the agent's survival and the extrinsic rewards, whether or not you have reached the goal or not by some extrinsic definitions. But I think there is a lot more to be done in terms of the endogenous objectives of the agents, right? How do we learn the representations without even having an external rewards? So what are these endogenous learning objectives? Well, first of all, in terms of the perception and memory, you could do the next latent prediction, as has been done in self-supervised learning in JEPA world models. And in terms of planning, you can do the planning in your latent space and, for example, do the latent goal reaching. And lastly, for exploration, you can form your intrinsic reward rather than let the external world tell you where to reach. And this leads to latent discovery. So I'm going to talk about what are the challenges. And as it goes, challenges also come with opportunities. So first of all, in the always learning paradigm, you will have to have the physical grounding, right? But these can also give you spatial temporal continuity as additional teaching signals that you wouldn't otherwise have with, say, static images on the internet. Secondly, there's very strong temporal correlations in these embodied videos, but on the other hand, you will get coherent episodic memory rather than something scattered like single sentence or a single piece of image. And if you're doing always learning, the continual learning will be a question here, right? Because you're optimizing towards the continuously moving target. But the benefit, the potential opportunity is that you may generalize to your current task better because you're optimizing to the current task rather than a collection of all the other tasks that are potentially irrelevant. And also, as you're changing the weights of the model in real time, you may find out you can collapse at the deployment. Maybe the learning objective isn't set up correctly. Maybe there is some collapsing mode in the model. So this is definitely one of the other challenges. But on the other hand, it allows you, the model, to explore the creative frontier. You can always create new things and add it to the collection of the experience of the model. whereas the offline trained model wouldn't have the same capability. So let me start out with introducing some of the work that our lab has done in these directions. So first of all, I'd like to talk about learning the high-level cognition and motion recognition. Okay, and this is a little timeline that the human brain, the babies, started to develop visual understanding in their early ages. So as soon as the 3rd month to the 6th month, first half a year, babies start to recognize objects with their object permanence and also recognizing moving objects very well. Okay? So it seems like these two capabilities doesn't give you all the way at the beginning, but start to emerge around the same time, same period of the life. So we are start wondering whether we could enable these two types of understanding, the object recognition and motion understanding, jointly in one model that learns to perceive the world. Well, standard self-supervised learning tries to throw out the motion information, try to map different views of the same object to the latent space, whereas action condition world model requires some external actions. What we would like to do is to model the motion or the transformation between the two adjacent frames as latent variables, so that once we have inferred these latent motion, we would be able to predict what comes up next very well. So we're interested in building these latent motion models. And on the other hand, we're also inspired by the classic computer vision model, which tries to estimate motion, aka optical flow. But in these classic models, they try to explicitly reason about motion in terms of the change in the XY coordinates, which we think is maybe a too rigid of a representation to represent motion. And we're interested instead to represent them in the latent space. But we took inspiration of how to build these models where we have these top-down hierarchies of having the very high-level motion information in the very top and gradually refine them layer over layer and try to predict using the latent motion variable to predict what comes up next in the intermediate layer of the next frame. So the objectives is laid out in a hierarchical manner, right, instead of just on the very top. And here is a little video showing you what kind of representation we're able to get by just doing unsupervised learning from self-driving videos, which is a form of embodied experience. And so you can see we can get very good semantic understanding. So this is a readout, probing results by using the representations. And so these are the semantic understanding. And what about motion? So we also try to evaluate the tracking and optical flow. And in both cases, we're able to achieve very nice results by only doing self-supervised, unsupervised learning from videos. So next up, we want to move this one step further, which is further restricting the data that we use for learning. So what is it like to gain visual understanding from a baby-like experience? Okay. So what we were trying to do is streaming visual learning. So previously we took a video and chop them up into consecutive frames and then do the unsupervised learning. So now we're going to do a continual streaming style. We will stream the video once in a lifetime, and we start out with a randomly initialized network, and then end up with a trained model, just like how baby sees the world with once in a lifetime. And we took egocentric video data sets that's about 200 hours from one single participant, one baby, over the course of 2.5 years. Let's see how far we can push down this road of streaming video learning. And one key question is, can we leverage the temporal continuity that's given from this data source, which is, I think, one of the opportunities that we can benefit from. And one insight I'm trying to push is, can we leverage the events that happen in this video, not just at the frame level, but try to cluster or group them in a higher level concept, such as the events or the key moments. So for example, the baby might be experiencing a reading event with their parents, and then watching their parents typing on computer, and then maybe then playing some toys in their own room. And these contents will get stored and grouped them in the memory, and they may get replayed and consolidated later when we try to learn the representations. So the research question here is, can event concept emerge and benefit streaming representation? Okay. So the answer is yes to both questions. The events concept can emerge even though the network has been completely trained from scratch. Over time, the events are getting better and better, and then we can also use these event boundaries to help the representation learning. So here is what it looks like in the algorithm that we designed. So we start out with a video. We're going to encode them with our encoder, and then we tried our best to cluster them into consecutive clips. Okay? And then we're going to group them further into non-consecutive segments. And these events will be first processing a short-term memory where we look at which frames are belonging together. And then we're going to store them in a longer-term memory, which is being used for replay when we watch the new video segments. It probably can remind us of something that happened in the past. Okay, so this is a two-tier memory system that's supporting this streaming and continual learning process. And so here is what we've done in the experiments. We took two data sets. One is the baby video data set that I just introduced, and the other is called Krishna Cam, which is collected by a grad student. So it's a different type of experience, but also egocentric. And so what we're looking at is the streaming learning performance of various kinds of continual learning models that doesn't consider the video as a temporally continuous data stream, which only consider them as a separate static frames. And also the IID performance, which is just randomly sampling from the whole video stream as if they are just separate images. And interestingly, our method is getting the best performance, and this is try to probe for the classification as well as the object detection performance from the trained encoder. So see how much representation they can gain from there, okay? And we're also compared to other prior work that treat the video as equal uniform segments, and of course the clustering helps it better. And here is what it looks like when the network is just being initialized. Of course, you can still get some similarities by comparing different frames. And after the training, you get better and better event concepts just because the features are getting better so that when you group them based on the similarity of their latent space, you'll get getting better event concepts. And you can also merge the events that are non-consecutive. For example, here is a person, likely the parents of the baby, sitting beside the desk, and you can see the same scene happens multiple times in the lifelong experience. And more recently, we pushed this even further, multimodal learning from the baby's lifelong video stream. And so what we did was transcribing the audio as well, and then doing the multimodal associative learning between the text and the video segments. Okay? So there are 3 different learning objectives: the image level, which I just introduced about, and the multimodal segments, which represents the video segments of where that text happened, okay? And also the temporal segments, which is the event concepts that's appeared in the previous algorithm. And so here are some of the experiment results. So we're comparing promisingly to the offline algorithm. So the first bar is kind of like upper bound because it trains for 300 epochs, whereas the second bar is a compute-matched experiments of IID learning, which means that you take the same number of gradient descent steps as our streaming algorithm, which doesn't look back when training. So we're kind of getting closer in terms of closing the gap. And here are some visualizations to see whether the learned encoder gets a proper representation associating the words and ground them into different pixels. So, from a baby-like experience, the network starting to gain the concept of what is a cat and what's a ball simply by listening to what their parents said to them in the video. So here, just to give you a recap on the agenda, we covered learning perception in a streaming video experience and also how to group them in the memory, associating them in the words. And next time, I'm going to talk a little bit about doing planning and exploration to kind of complete this closed loop cycle. So now with a good latent space that we just learned from watching videos, one thing that you could do as a downstream task, other than just doing object detection or classification, is that you can actually do some planning with the latent space. So this paradigm is called latent world models and model predictive control, which has been developed over the last few years following this JEPA paradigm, where you embed your current observations in the latent space and try to minimize the latent distance towards the embedding of the goal state. Okay, so you can do some planning with your action condition world model and trying to minimize that overall distance to the goal. So what we're trying to do here is, always learning. So we try to, kind of adapt this encoder and predictor of this world model every single observation that comes into the agent. And this idea of adaptive and model predictive control isn't new. It actually has been pursued in the control literature and neuroscience literature for decades. But I guess what's new here is that we're also adapting the entire model with a latent space representation, whereas the past literature mostly adapts in the dynamic space. So in the latent space, we have to continuously ground the encoder and get it to be corrected, because if your predictor has some error in the latent space, the error can amplify over multiple steps, and which can lead to lowering your planning success. And so this is a recent work called ADA-JEPA, which is Adaptive JEPA World Model. The idea is very simple. So we try to at test time adapt our encoder and predictor in a closed loop, right? So we take, using a world model, make a plan here in the latent space, and we take the action that optimizes the plan, right, in the real world, and then we take a new observation and compare that with our predicted rollouts. And of course, there is some predictive errors. We're going to adapt our encoder, predictor, everything in our model by minimizing that predictive errors. And then we do replan again to take the next step. Okay, so there's a very simple idea, making the world model more adaptive and minimizing latent prediction error. And every closed loop step, we're also just making one gradient step on the encoder and the predictor, so that we are not taking too much overhead, making the whole thing adaptive. So here are some results. These are toy embodied environments. The goal is to move this piece, the little toy block, to the target location. And here we are seeing the success rate over time, where the dashed line is the frozen model that's non-adaptive, so they kind of stuck in the middle because of this prediction errors, even though some of the shapes have been trained with thousands of trajectories. And the solid lines are our adaptive JEPA world model planning. It gets much better in terms of planning success. And I'd like to share this one plot for training data efficiency, which I found very interesting. Where here we're kind of scaling the number of trajectories and number of shapes that we train the model. So typically you would expect, like scale the offline pre-training data, but definitely leads to some improvement, and this is indeed the case. But if you look at the lines over here, which is the adaptive ones, even if you train with, say, just 1,000 trajectories, right, with a single shape that's about this current task, what this shape is about, it actually outperforms an offline model that has seen like 64,000 trajectories, which is great because now this proves that this adaptive learning paradigm has the potential of saving a lot of more training data if you only care about optimizing the current task. So here is a little bit of a pivot towards the last part of my talk, which is more about the exploration, which is the final piece of this closed loop learning. So always learning embodied agents, right, learn from the observations that are caused by their prior actions. Okay, so the action matters not only for optimizing the agent's short-term goal, which is probably reaching an object in a few seconds later, but also the long-term learning of the knowledge and representations. Okay, so this is a notoriously hard problem in reinforcement learning because this long-term credit assignment problem is hard. And here what we need is creative exploration, which help us build representations while interacting with the world. Okay, but before approaching to this question, the question is really, what is creativity fundamentally? So here is kind of a mental picture of understanding creativity. Some people say it's about novelty, but I think it's only half of the puzzle, right? So novelty is not enough for creativity. You can have a randomly generated white noise that has zero meaning to you, but is absolutely novel to that hasn't seen before in this world. Okay, so what you want for creativity is something that's initially unfamiliar to you, but can be quickly understandable through some rapid learning. So if you think of this manifold containing a lot of existing concepts that you understand very well, creativity is kind of lying on the boundary that's not part of your existing concepts, but can be quickly absorbed by expanding this frontier of understanding. And I should say that, so this notion is also deeply related to prior literature. For example, from Schmidhuber in 2010, he proposed using compression progress as a notion of creativity, which is more of on the pure theoretical side. And more recently, on Perplexity, which is trying to measure the structure of data. And here, what I'm going to tell you later is more of an instantiation of this creativity notion in a meta-learning framework. But to summarize this slide, what I'm trying to say is creativity is deeply bound to the past experience of the agent. So there's no objective notion of creativity. So the frontier of the understanding of the subjective agent's subjective representation slowly expands so that it keep continuously absorb the creative concepts. So this is a recent project. We didn't touch upon the embodied aspects, which we're just trying to do more of an image generation experiments. And here is a model on what I call the creator-appraiser meta-learning. So the creator tries to create some artifact and present it to the appraiser. And the appraiser internally tries to understand what's going on by minimizing some inner objectives. So this can be auto-encoding by doing reconstruction about this input, or can be other objectives that I'll talk about later. And the creator's goal is to maximize the learning progress of the appraiser within a few steps, so that it appears initially very unfamiliar and perplexing to the appraiser, but only after a few steps it can be rapidly learned. So here are some very toy experiments I trained on MNIST, which the model, both the creator and appraiser have only seen MNIST digits, which is 0 to 9 handwritten digits in their entire life. And here the appraiser is simply an autoencoder, try to reconstruct the image. Okay, so if you use a diffusion model and not guiding it, just doing unconditional sampling, you will get digits really look like 0 to 9, nothing very interesting here. And if you introduce this appraiser and ask the creator to maximize the surprise and learning progress, you will get some very interesting handwritten-like characters that at least I haven't seen before, but sometimes looks like different components of the digits. So that's very interesting. So now let's move to natural images. And what I used here is a stable diffusion generator and a clip appraiser. So the clip appraiser tries to maximize the cosine similarity between the image and the text internally in its learning objective. And what's important here is that I'm using the same prompt for every single image. This is a photo of something. Right? I'm not trying to be creative in the language space, but the creator is trying to optimize the latent embedding of this whole sentence through the learning process, so that it might be implicitly finding some creative prompts, but I'm not actively looking for them in the raw language tokens. And here are some samples. So if you sample from stable diffusion model, they're just like, this is a photo of a lion. It's always a lion that looks like a photo that you took on the African safari. And also this flower photo is always similar if you sample from this prompt, I guess. But once we introduce the appraiser, it gets very interesting. This one looks like an autumn leaf with a side face that you almost never see when you do the regular generation. And I like to zoom in here. This flower was very interesting to me because, the center looks like an egg yolk rather than a regular flower. And all the edges are kind of rectangular, not like kind of the regular natural shape of the flower. And this one gets even a little bit more black and white and abstract space. And so far this piece of work handles more on the image generation side, but I thought it's potentially a nice direction towards creative exploration in different modalities. To sum up, so here I introduced this direction of always learning machine from embodied experience. And it has many components in there in a closed loop: the perception, memory, planning, and exploration. And importantly, we try to define the endogenous learning objectives that shape the latent representations throughout this closed loop. And to close up, I'd like to also say there are many open questions in this paradigm, and so far we haven't solved at all. And so first of all, like once you do this always learning, adapting the parameters in a closed loop, how do you form the episodic memory? Right? So maybe there's another way than just stacking up the tokens in a sequence. Maybe the gradient descent process gives you some time ordering awareness. And this is also another topic that I was planning to talk about in today's talk, but found they can't fit in the slides. It's more about the self model versus the world model. So as the agent try to model the world, maybe it's also in parallel trying to model the agent itself. And there's also the stability versus plasticity problem that has been a classic problem forever in continual learning. So what do we retain in our representation? What do we throw away and then learn new representations? How do we control this balance and trade-off? And perhaps there's meta-level controls. Maybe the agents could control what can be learned in this embodied experience. Maybe I see some, maybe I enter a blackout room, and then maybe I tell myself I don't learn from the lack of experience at all, right? Because it could potentially lead to collapse of my my representations. And perhaps the agent could form latent goals by trying to plan out more longer horizon goals and then forming its own latent intentions and goals. And there's also the exogenous versus endogenous gap. For example, the RL is probably the ultimate solution, but what kind of outer level objectives will lead to this inner level representation learning objectives? And are they equivalent, or can we find things that are more equivalent than two completely separate paradigms? And with that, I'd like to acknowledge my amazing students who contribute to the work, and also the funding agencies, and especially the Global AI Frontier Lab, which fund a portion of the research I presented today. Thank you very much.
Thank you, Mengye, for your excellent presentation. We now have time for a few questions from the audience. If you have a question, please raise your hand, and a staff member will bring you a microphone. Any questions from the audience? So let me start up a question. Thank you for your excellent presentation. It was very motivating. The concept that you mentioned about episodic memory, I was wondering, it seems like inspired by the human recognition or understanding. Some of the episodes people memorize forever, from the entire life, even seeing at once. But sometimes other type of episodes you keep forget, even though you saw it many times. What do you think the main reason, do you see similar behavior in the neural networks or AI models? Similar thing happens, or if you saw some similar episode observations, what is your insight? Why these things happen, and how you can overcome these issues?
Yeah, I think it's a fascinating question. I don't have a full answer to it, but I think one of the driving principle is that these agents are doing error prediction, error minimization in this predictive process. So if there is a larger surprise in terms of the error prediction, it makes sense for them to store these surprisal moments for longer term. But I should say there's also other types of meta-level controls where I control where I kind of snapshot the current moment for it to memorize in the longer term. And also the human memory is oftentimes associative, meaning that it stores many moments, but it's just that we don't retrieve them unconditionally. We kind of need some conditioning in the cues to be able to retrieve them. So we also study in multimodal learning, what's the best replay strategy? When I see this chair, maybe it reminds me of some other chairs that's semantically relevant, but maybe providing different shapes and content, and this could potentially help multimodal learnings, and this also an area of our interest.
Right, thank you. Some other questions from the audience? Yeah.
Thank you for the great talk. I'm a neuroscientist, so I was mostly intrigued by you mentioning the coincidence between co-occurrence of the movement of baby with visual development. I was wondering, there is certain brain functions, like visual functions, that can be developed even without any visual stimuli, visual experiences. So whether you could give your thought about like how those priors can be implemented in the AI models. And then second, there is also like critical period in the development of babies, and then how that could be also used to improve the I don't know, like AI more brain-like.
Yep. Thanks for the question. Yeah. So I'm not a neuroscientist, so I will give my 2 cents on the question that you just asked. So one of the things that we are currently very interested in studying is how can we leverage some synthetic visual stimulus. For example, this is inspired by works in these retinal waves, which happened, even before birth of the baby. They start to synthesize these retinal stimulus, and we thought that could be a good source of doing pre-training for the networks to gain these, primal kind of motion awareness. So this is one piece of insight. And the other is about the critical period, which I think could also very much align with the neural network training. There's a phase where the errors get decreased by a lot, and then later in the fine-tuning or post-training stage, you don't get to change the representation so much. It's more like in locally in a basin in the lost landscape. But these are very hand-wavy, high-level sort of associations of different concepts. So I don't try to make a claim on the strong connections.
I think we have a few more moments for our last question. Any question from audience? All right. I will finish with my last question then. Since it is a multimodal AI, what do you believe, other than you talked about the retina waves, but what type of other modalities do you think could be incorporated in always learning paradigm?
Yeah, I think it depends on what type of agents that you like to build and what kind of sensory experience we have. Like, I think audio definitely makes a lot of sense, right? I think perhaps touch or maybe sometimes smell, can be additional source of information that are very good. And yeah, I think having all these in an embodied agent will be a very exciting direction for multimodal AI. Yeah.
Okay, thank you. Thank you once again for your insightful presentation. Please give him one round of applause. Thank you. All right, now let us begin the panel discussion. Please join me in welcoming today's panelists. John Ponce, who is a professor at École Normale Supérieure, PSL, and Xiaoning Xie, who is also a professor at New York University, Yoon Kim, who is a CSO of 12 Labs, Suha Kwak, who is a professor at Postdoc, and Nako Song, who is a head of hyperscale AI at Naver Cloud. Please welcome them with a warm round of applause. All right, so welcome everyone. So to help structure our discussion, I have prepared 4 broad themes accompanied with a few questions. But it is a guiding questions to initiate the discussion, so you are feel free to reframe the themes and and then just share your perspectives and experiences. So the first theme that we are going to talk about The first thing that we are going to talk about is the next frontier of multimodal AI. And here are some questions that I have prepared. So the first question is, what do you see as the biggest open challenge or opportunity in multimodal AI today? And are we moving toward truly multimodal intelligence or toward the modality agnostic AI that can just seamlessly integrate and reason across any type of data? And the last question is, which current assumptions in multimodal AI research do you believe should be challenged? Anyone who volunteered to speak up first?
I can, if you
Thank you.
So hello, I'm Jean-Paul. So I'm not only from École Normale, but also in NYU, so I have plenty of colleagues here. So I'm not sure I say any of this question really, but I thought a little bit. So to me, first, multimodality is really important. It's obvious for everybody. I think what I'm going to say is going to be obvious for most people in general. I think multimodality is important because of interfaces to intelligent agents. So I had lunch with Korean colleagues, and in old sci-fi movies, you had the universal translator in your ears. That would be really useful. So I think this is obviously important for that, but also tasks and domains that are inherently multimodal. If you want to have robots, they will need to see, they need to touch, they will need to know where they are, they will need to sense their configurations, they will need to have to understand their controls, torques and forces, they will need to have touch. Maybe they will need to hear and speak and read, I don't know, I'm not so sure about that. But this is clearly a fundamental issue in this kind of domains. Also, from a representation learning point of view, maybe not from a prediction thing, but representation learning, I think there are at least two issues that should be addressed, and it's between Q1 and Q3, I think. One is multimodal AI is mixing apples and oranges. So an image and a piece of text and a sound waveform are not the same. They don't have the same structure. So for example, text and speech have a linear structure corresponding to the temporal evolution. Video have the same kind of structure, but static images don't. It's a bit artificial to use transformers on images by splitting the images into tokens, because the order is non-canonical, so it's a bit bizarre. Also, when you take, say, two sound waveforms, you can add them. That's perfectly legit. That's what, when you hear each other, the sounds overlap. You cannot add two images. You cannot add two pieces of text. So we are in what you would like, if you want to map different modalities to a common space, you would like to kind of morphism thing, something that preserves structure. But the structure of these different modalities is very different from one to the next. So you have this kind of, I'm sorry, I took some notes, you have this kind of geometric representation issues. You have a problem of units. Like lengths and angles are not commensurable. So if you have different modalities, they will have different units maybe that cannot be compared. How do you deal with that? I think nowadays, a lot of what is done with multimodal data for representation learning is you embed, you don't really embed, you create some feature space that for some reason people call latent space nowadays, I'm not sure why. You create some feature space and then maybe you have some kind of projector that will project everything to some common space, and then you concatenate these things. And not especially some multimodal data, but for an outsider, this is kind of bizarre because again, those are very, very different objects. What I think is interesting is that obviously the human brain can do it because we use touch, taste, smell, vision, hearing, and all that, and we manage to combine them. I have no idea how the brain works, but I think it's probably unlikely there's some kind of projection in some common latent space. So maybe we can learn something from that. Mengye earlier mentioned, babies learning to recognize stuff. I don't know, actually, I'm not a psychologist or neuroscientist, but I'm not sure how important object recognition is really in people or in animals. We see a lot of, for many other things, like moving around and manipulating and all that. So another example, I'm sure you will hear a lot about, and we heard a little bit about them, about world models and planning and all that. And people talk a lot about doing hierarchical methods, hierarchical representation. I do not know how to cut space into chunks. I know how to cut time into chunks because it's a linear thing. I halve it, and then even normal 3D space, cutting into meaningful chunks, I don't know. I mean, this feature space, I have no idea how to do it. So I think that, especially with these multimodal models that have to encompass a lot of different data, I think this is very difficult. And finally, and I will stop after that, there's of course, again, I said I would state the obvious, a problem of scale. Of course, LLMs have access to billions and zillions and quadrillions of text data. Nowadays, there are people everywhere that put on goggles and film millions of hours of manipulation stuff. But the scale is difficult, in particular in domains like robotics, where the platforms are very different. It's a domain where I'm always a bit puzzled, where people talk about generalization. To me, generalization to new tasks, generalization to new robots, it's kind of a funny thing to do. Normally, if you have one robot, you'll be happy with that robot. But in that domain, capturing enough data that can be useful for precise tasks is difficult. And of course, people are resorting to simulations. But there are at least two problems with simulation, again with multimodal data. One is that your simulator has to be physically realistic, and I think most simulators available today are not physically realistic. The other one is that to generate interesting and pertinent simulated data, for example, we need to generate interesting and pertinent trajectories. We don't know how to do that in simulation, or maybe we do, but doing it involves solving complicated planning problems. For example, you want to record all the joint things and all the images that the robot does in simulation along some trajectory. The trajectory, for it to be interesting, it's probably cannot be just random trajectory. It has to do some tasks, maybe avoid some obstacles, and generating those is already very, very difficult. So I think there are tons of difficult issues facing us for representation learning in multimodal data. Thank you.
Thank you.
I'll just follow up on Jean's comments. Thank you for mentioning 12 labs. I think the biggest open challenge is the meta problem of figuring out this open challenge, because there's so many aspects of multimodal understanding that we have historically considered as hard. With the plethora of information and data and processing and GPUs, I think that it's time for us to really examine whether using images to understand the spatial temporal characteristics of this world, particularly continuum videos, is the right approach. We at 12 Labs think it's not the right approach of trying to use images perhaps once a second, and that's 3,600 frames per hour, and feeding it to an LLM. To me, it sounds like multimodal learning. It's nothing but an extended concept of a transformer that uses different modalities in it, and then it boils down to then, as John mentioned, what type of representations, how do you tokenize things, how do you resolve the different temporal resolutions of audio, video, text, image, and language, and then how do you resolve it in a way that is very, very efficient. So there's a brute force way of doing it, which is to throw everything in the kitchen sink. Unfortunately, unlike text, where we can throw everything in the kitchen sink, and the LLM amazingly works well, we can't throw everything in the kitchen sink, even if we had the world's videos, because that will probably drain most of the GPUs that Jensen Huang has produced. So I think that the biggest challenge right now is to figure out what the main chunks of the problems are, what problems we're solving. And specifically, I want to point out that viewing large language models as a basis for multimodal AI models probably is not the right approach, that we have to figure out a different, perhaps an orthogonal approach that complements linguistic intelligence. And I'm sure that the other panelists have figured out in their own rights what they want to pursue, whether that's world models, learning, whether that's action, whether that's through some content understanding. So it's a fascinating problem. I think we're just scratching the surface, and I have a feeling that the surface of this ball is very, very, is going to be large. So
maybe before starting my speak, I should apologize for my broken English first. and I'm a practitioner. I had started my LLM project about 4 years ago, so I have some experience with multimodality. And as we all know, we had started with this large scale model with text modality, only text modality, but nowadays we expand to video, image, video, audio, or something like that. But actually, text is a compressed form in the across the along the human history of maybe 100,000 years old. And we also apply some BPE, another compression method, to the streams of tokens. But video streams or audio streams are naturally raw streams of recording. Is just a flat rate recording. So the density of the information across the time axis is very not uniform, very different from text modality. That is why I think there is the reason there is a difficulty to mix those modalities together. And as we talk about multimodality, but the number of modalities are very small. Number of modalities are very small. That leads to us to lack of generalization capability across the modalities. So if we want to truly multimodal model, we should augment the modalities. And in the computer vision literature, we have invented kinds of augmentation techniques. And actually, the realities are real, and the modalities are just augmentation by the nature. The video, vision, or audio is just a recording in one aspect. So we can add, or we can simulate, we can augment some arbitrary modalities. By doing that, maybe we can make some 1,000 or 100,000 modalities, and with the kinds of data, we can pre-train those kinds of strings. Maybe we can get some generalized capabilities across the modalities, maybe zero-shot modality. Maybe we can record this room with video recordings or some thermometer or some kind of other tabular form. Maybe it is just another recording or just another aspect of the realities. I think the biggest open challenge for multimodality is dealing with some small number of modalities. That leads us to not true multimodality. Actually, I'm experiencing the lack of cross-modality capabilities. Actually, most of multimodal benchmarks are dealing with modality translation. It is just like image to video, video to image, or some kind of things. Very limited. But it is not the expected capabilities we do. I think that this is our open challenge, and then maybe the main opportunity for researchers is open to everyone. I think.
Thank you. Any other panels to add on top of it?
I think I'm not a right person to claim the biggest open challenge in multimodal AI, but I'd like to narrow down our focus on some small technical aspect of multimodal AI learning. I think one big challenge of learning multimodal AI is the polysemy of data and their multifaceted interaction or relationships. So for example, images may contain multiple types of objects, and pairs of such objects may show some different interactions in a single image. And also audio may be featured by multiple sound sources. And on the other hand, the text is too abstract, so it can be realized to countless variations of images and for example, audios. But many multimodal AI, foundation models of multimodal AI models have been trained using contrastive learning, which relies on matched or unmatched relationships, the binary crossover relationship. So I think this kind of training strategy does not reflect the real relationships of multimodal data in the real world. Especially in the deployment time, it's almost impossible to curate the acquired data. So the data are usually polysemy, and also their relationships are not single-based. So I think we have to resolve this issue for achieving true and more useful multimodal AI model. Yeah, that's my answer for the question 1. Do I have to answer to the other 2 questions now?
Yeah. If you have any ideas to add on,
Okay.
you can keep going.
So for question 3, I think this is connected to my answer to the first question. So we have to challenge the assumption of binary crossover relationship to learn better multimodal AI models that can work in real world. And I have noted. And I think people believe that a single multimodal AI system that can handle all possible modalities and all possible tasks is the ultimate goal of multimodal AI research, but I don't think so. So we may challenge this assumption too. For example, there are a huge number of highly capable and readily available multimodal AI models on the web, and it would be also important to establish infrastructures to orchestrate those models to solve many different types of multimodal AI reasoning tasks. And also, I guess many people believe that adding more and more modalities, input modalities, will lead to improved performance or reasoning capability, but it may not be true. So for example, for video understanding, sometimes, the videos usually comes with 2 different modalities, video and the frame images. But for example, for video question answering, sometimes audio modalities is quite useful, but sometimes not, or even they degrade the reasoning capability, especially when the audios contain some noisy information, or for example, background music is totally irrelevant to the video content, the image frames. So I think the multimodal AI systems have to have some capability to choose the input modalities according to the context and the task dynamically. And for question 2, I do not clearly understand what is the truly multimodal intelligence, especially regarding how it differs from the modality agnostic AI.
So what I meant by truly multimodal intelligence is understanding every multimodalities at the same time. You can just play with it. Modality agnostic AI means more like it's a plug and play model, such that you have different modalities, you have a embedding of that modality, and then just put it into a bigger AI model that can agnostically play with it.
I'm not sure, but I think both approaches are being pursued at this moment. But I personally think modalist agnostic AI has some limitations or some difficulties to achieve. Marco already mentioned some of the issues, like data scarcity. So some modalities will come with very small amount of data points available. So, and usually modality agnostic AI or representation relies on a single joint embedding space that's shared by all the different modalities. And I think this is not natural, as John mentioned, and it's not achievable in the real world. So I think it's much better to translate a modality to another. And we don't have to build a single joint embedding space for all the modalities. I mean, the modality agnostic AI. But I'm not sure whether this is the right answer to the question too. Anyway, that's my answer.
Can I add on?
Yeah,
What I suggested is a kind of a sub-modality augmentation technique, because the current we are seeing with RGB that this is spectral configuration is only for human being, and the other species has different configuration. Some species sees through sounds. Some species sees through, I don't know. Have you watched Hail Mary? Yeah, yeah. We can apply various kinds of augmentation. Let's say imaging for video. Video has various configuration of different resolutions or frame rates, or maybe or different angles. So if we can access some source of data, we can augment by adding extra sensors, or we can tweak. I think this is maybe affordable starting point for the multimodal experiments.
Thank you.
My turn?
Yeah.
Okay. I'm signing here, but I'm from NYU, but I'm also a co-founder at MA Labs. So in terms of like multimodal AI, I think I have like two hot takes. And the first one is I think language or text should be kicked out from definition of multimodal. When people are thinking about like multimodal AI right now, most of the time people think like language versus vision. But again, my take is like we should really kick language out of this. So the definition of modality is really about like, for example, like vision, audio, smell, as John mentioned, but also like different kind of sensors in the world that can give us high-dimensional continuous space and very noisy kind of data. And then on top of this, we'll have language, which serves as communication interface. It should not be one of the modality in this kind of core modeling. And then I guess like, Professor Lee already set up these questions, kind of like basically alluding to my take, in the sense like you care about, a modality agnostic AI, then it's not just like text and vision, maybe like covering many different modalities in the real world. I think this is definitely the right direction. And the second hot take is actually what Mr. King just mentioned already. I think we should really rethink the role of large language models in core kind of multimodal modeling. Like right now, it's really puzzling, and like for all the multimodal AI stuff that we're doing, like we're always designing the whole system around the language capabilities, around like base large language model system, which is like really bizarre because for a lot of this continuous space high-dimensional modeling, you don't want to first kind of go through the language models, or first just like go through some encoders and then align everything to the language space. In contrast, what we should do is we build another different type of multimodal native model that can really handle this continuous space signal well. And then the language model can be just like an interface on top of it. So again, I feel like this is definitely the biggest kind of open challenge, but also like great opportunity in front of us.
Thank you. And as a topic for like next frontier, we have been collecting sensor observations or measurements in a way that we can interact with human, or they can interact with some simple machinery or circuits. In that point of view, if we have like truly multimodal AI, do you believe how we develop sensors can change totally, or do you still believe sensors can be observed as it is or developed as it is, but we have a way to handle this type of sensor observations? Maybe John, you want to start?
So you are talking about developing new sensors? Is that what you
Yeah,
said?
like we have like, for example, biosensors, biosignals.
Oh, wow.
Yeah, we measure them as if for clinicians to understand, or sensors from the industry, we want to investigate something. So the sensor observation should be in a way that human can interact with.
And I'm not sure it should be in a way that people can interact with. I think, so I take robotics as an example. I think having robots interact with people is very hard. Robots are dangerous. I mean, if you have a humanoid 2 meter tall or 6 foot tall, and because to control itself, it's big, it has mass, and so if it bumps into you, it might kill you. So eventually, you want to have intelligent machines that interact with us, but I think we'll be happy if they do some things on their own that are useful, like having robots in a factory being effective. I think, of course, we need sensors adapted to tasks. And so, what do I know? But I imagine that the idea that you develop a general AI that's going to be useful for every possible task and will handle any possible sensors, I'm not convinced it's true. But I think we need all the sensors that are necessary for a given task. I'm going to say 2 things, maybe. One is, I kind of agree with him, is that language is not necessarily the central part. For example, I'm amazed by what you can do with LLMs. The first time I put an image into Gemini and asked, read me the text, it did, right? So that's, I think, truly amazing. But it doesn't necessarily have to be the central part of what we do. For example, I'm always a bit puzzled about VLMs, VLAs. I never understood which one is which. There are tasks right now that we do, again, in robotics, which is you give robots billions of text stuff and a big LLM and a big VLA and things trained and whatever. Then you put the robot in my office that he has never seen, in a building that he has never seen, with the door to my office is closed, and I'm supposed to show the robot a picture of, say, the washroom, and tell it, because it's very important, tell it instead of saying go to XYZ, tell it go to the bathroom that looks like this. And the robot, which is in my office, has never seen, a building it has never seen, is supposed to go and find the bathroom. And I think that kind of task is a bit puzzling. So I think it's very important to use all these different sources of data, but I think we need to have a realistic way of doing it. I also think for many tasks, what we do then which is collecting zillions of hours of whatever, and then learning a black box that we can, either it's a black box or we say, it's a world model and we're doing this and that, and then at the end we are going to solve a big a big non-linear least squares problem, and that we solve our problems, maybe a bit naive for many things. And I think that in many problems in AI, and again, particularly in robotics, you don't need to learn everything. You need to use all the data that's pertinent, but there are things that you know and things that you don't need to learn. So this is maybe more about the challenging the current assumptions and answering your questions. But I think these issues, I think should talk about, you think about, and I always repeat the same thing, and I copy my elders, but I always point people to a blog by Rod Brooks, where he said he challenges the idea that you can learn to manipulate objects by just watching zillions of hours of video of people doing that. And shows video in some psychology lab in Sweden. I was in Pohang and I showed that to the student. And we have a person whose fingertips have been anesthetized. Just the fingertips, so they cannot feel the touch. Otherwise, they can feel the effort on their arms and they can see everything. And this video is painful to watch because the person has to scratch a match against a matchbox. It takes that person 10 minutes. It's actually painful to watch. So I think we need to be a little bit careful about how we specify our task, and the idea that just observing the world for thousands and millions of hours will solve the problem. I think should be challenged in the multimodal world.
Thank you. Can I actually go back to your question about sensors? Yeah. I find it a really interesting question because I feel like we're in a golden age to really rethink the problem from both directions. Because before, we just handle internet distribution, kind of like videos and images. But now we should really think about like building AI solutions, building AI models that can handle really kind of like, different modalities from different kind of sensors in the real world. Data are there, like there's tons of sensors capturing like all the signals, in all kinds of kind of like economic sectors. But we don't have kind of good modeling approach. Apparently, large language models is not going to be enough. But on the other direction, I feel like it's really interesting to think about, once we have this kind of cool modeling approaches, once our AI, like intelligence keeps kind of like going up, how do we design new sensors that can more efficiently and effectively can capture, like the data that we care about, right? Like, I'm wearing different kind of sensors like the Whoop and, like Apple Watch and whatever. It captures all the systems, but I feel like the intelligence part still kind of lag behind. So I really think there's kind of co-design process that can happen and should happen in this space, which is very exciting.
Thank you.
If I may challenge that, we already don't know really how to integrate the data that we have from existing sensors, and pretty much all we use is some video and some text. And so maybe we start by using all the data and the sensors that are available, and then we develop more sensors, maybe.
I have something to share with you. Actually, it has been 5 years since my first LLM has been trained. So in the early stage of LLM, there was a debate if we could have such capability to retrieve some knowledge written in language A by querying in language B. Is just like this kind of problem. But nowadays, everybody knows that it is fully natural to query in arbitrary language. What's the difference? What made that difference? We have surpassed the chinchilla optimal. We have put enormous amount of data with the enormous amount of compute, and the alignment or joint embedding has been emerged. I hope that it will be generated, reoccur with this multimodal setup. But to do that, as I mentioned earlier, the abundance of modalities are required, I think. So let's think about the MCP, because I have a root on LLM. Early days of LLM, we had a feature called tool calling or fine-tuning to fulfill some kind of APAC calling. But nowadays, everybody knows that we have some kind of tool descriptor, and we feed in the tool descriptor, and the AI model can act on arbitrary function call or function APIs. I think that we could reimagine our multimodal setup. Actually, our multimodal setup is just hardwired with hard-coded encoders with decoders with the LLM backbone, language model backbone. Instead of doing that, maybe we can plot some kind of modality descriptor. Maybe it can be translated with another LLM encoders with the bottleneck of latent space. Maybe with this kind of setup, maybe we can find some kind of another emergence of the cross modality between even between text and multimodal or time series or tabular. This is my hope.
Maybe this is a segue to your next theme, but at 12 Labs, we aim to develop something called the video superintelligence by looking at the data videos that we process from publicly available information as well as customers. The thing that we learned in processing tens of millions of hours of video is that, as Professor Ren mentioned, if you want to do something really useful with intelligence, you have to have not only the perception layer, but also you have to figure out and learn and try to see how memory or store of knowledge and memory, knowledge graphs, knowledge bases would help in the understanding around planning, reasoning, action, feedback, learning. So we're right now at 12 Labs, we're going beyond models, because models can only give you certain inputs and outputs. For instance, video language models, the video is the input and the language output is the output. Same with embedding models, it's input and output. But as we know, agentic systems need to use these types of tools to solve tasks. So we're trying to solve real-world problems with the current state-of-the-art models. It's very difficult, but I think it's a worthy challenge. The biggest challenge we have as a company is how to formulate the framework of what visual or audio-visual memory is, and how to use it for purposes of understanding and reasoning in a way that is technically feasible. Also, I would argue that streams of audio-video, as John mentions, are very different than streams of speech even, because speech is nothing but a representation of the linguistic information that gets produced by humans. Video and audio, on the other hand, are representations of this world, where things and events and different environments give you sensors. And we've had smartphone cameras and CCTV cameras and other types of microphones and other multimodal sensors to capture some of it, but we don't capture everything. So when we're tasked with a problem, hey, we need to find out patterns of crimes and or other irregular, illegal activities in a given region with 1,000 CCTVs where we have 5 years worth of streams data. We not only have to go through spatial temporal reasoning, we also have to go through multiple streams and how they correlate, because they are representations of the physical world captured in different angles or different heights. And it's a problem that I think is quite different than predicting the next token via a language that has been encoded primarily for human communication. So I think there lies the challenge and the fun of figuring this out.
Thank you. I think we smoothly moved on to the theme number 2, theme number 3. Let's go this one first. What is the multimodal AI is, like how we should expand beyond the vision and language. Many of you guys already shared your perspective. So let me just briefly recap about the questions for the audience, and then we can keep going on this same topic. So my questions were, what breaks when we move from image, text, audio to tabular time series or even biomedical signals? Do scaling laws even apply when data is scarce or proprietary, which is often the case in real life? Second question was, what breakthroughs are needed to enable seamless reasoning across increasingly diverse modalities? Question number 3 is, which application domains do you believe will benefit most from the next generation of multimodal AI? I also share your views on language models are not enough for multimodal AI. The main reason is languages are in some sense it captures some conceptual understanding, human recognition as a natural language. So the many things that work well in LLM-based models might not work well on multimodal AI because different modalities might have shared different concepts or observations or information. Can we move on to this topic and share your perspectives and experiences of what should expand beyond vision and language?
Yeah, I'll just say that image, text, audio are just data that we've collected for purposes of humans. We're seeing a lot of interesting phenomenon for just even our video foundation models. We have 2 models. One is an embedding model that turns video into vector embeddings for search, and the other is video to language model. Quite recently, we have discovered that the APIs that we expose are no longer just accessed by developers, humans. They're accessed by agents. Now, these agents are simple right now. But in the world of agents that solve maybe different problems, maybe they have different requirements, I see this as a very interesting phenomenon where the entire architecture needs to be conducive for agent access of information. I also have to say that image text audio is maybe a representation of what we see. So it's human perception. So things like touch and smell are natural extensions of it for humanoids. For tabular time series laser LiDAR type of, we don't really have LiDAR sensors in our bodies. So I think that type of multimodality is perhaps a different dimension that we would want to use. And I would argue that if you do really well in those two dimensions, one is human perception-related extensions and modalities, and the other is, as you say, time series or biomedical signals for certain purposes that machines actually are really good at doing. The combination of the two groups of modalities could maybe offer certain things in intelligence that is not really explorable. But everything boils down to what type of data can we get, what type of high-fidelity data at scale can we get, and what are some of the exciting new form factors, like wearables or other types of devices people carry around that have sensors that would create data. Audio data is maybe natural, but perhaps there are other types of data that these devices collect. So I think that it's a little dangerous to conflate the human perception modalities with the machine modalities in the signals.
Thank you.
Okay, sorry. Actually, with the BERT, yeah, we can do some limited number of tasks, and after the instructor GPT, we can get arbitrary tasks to be fulfilled. So I think I mentioned many times before, the modalities should be generalized. If once the generalization across the modalities has been achieved, maybe we could do some fascinating work, like what I'm imagining is the kind of a USB device like AI, USB, Universal Serial Bus, maybe. Before USB, we had a dedicated port for every peripheral devices. For printers, we had a parallel port, a mouse for, I forgot the name, a PS2 port, maybe. But nowadays, we are standardized form. So maybe after that, we had such a kind of multimodality agnostic USB-like I/O multi-channel AI system. Maybe we can plug some kind of a new modality sensor and a new modality output actuators. That could be just converted into some kind of robotic system or intelligent being, maybe even more intelligent building, because every building has tons of CCTVs and elevators or some kind of actuators or something like that. Maybe we can transform those kind of IoT-enabled system into intelligent one. That is the answer for question number 3.
So, if I may, taking advantage of all the infrastructure and surveillance cameras and wearables and all that, it's rich, but there's privacy issues. I don't want to be tracked. I don't want my books to be read, for free. And I'm not an artist, but artists imagine. And of course, I'm stating again the obvious, but the scarcity and the proprietary thing. What data is not proprietary? I mean, really. And when a big company, develops an LLM or whatever AI they are doing, I imagine that most of the times they do buy a license from a provider, and that license, I imagine, doesn't allow them, even if they wanted, to give it to the general public. So I think the scarcity of data, hopefully, it's a shame, we will always be present. Data always belongs, like in vision. People have used pictures from the internet for so long, but the pictures do not belong to the internet. They belong to the photographer. And people have neglected that for a long time. And even in Europe, I think they're strong. There is some fair usage thing, blah blah blah. But in the end, these issues have to be faced. And if there are sensors that are close to the body and to what people do every day, I think we have to be a little bit careful. Again, that's obvious.
Thank you for your perspective. Yeah.
Yeah, maybe I can say a few things. And first of all, to Mr. Kim, I agree with you. I think, there are two kind of directions, but I'm not sure if they're really totally orthogonal. I think we have the first benchmark is basically us, the humans. We're not there yet. We're like very much worse than humans. All this, sensing capabilities. And then for other modalities like LiDAR and so on, to me, this is kind of like form of super sensing, right? It's like, goes beyond like human sensing capabilities. But I'm actually very bullish that we can actually find a universal methodology that can handle all this high-dimensional continuous signals. They might not be just like one single checkpoint, like one model, but in terms of like the modeling, paradigm, I feel like they can share many components. Yeah, that's my take, and also really appreciate Jinyoung, your comments on privacy and safety. I don't know if you have you watched a show called POI, Person of Interest. It's a very old American kind of show. They have this term called ASI in the show, and the way that they achieve ASI is by accessing all the kind of surveillance kind of cameras and your cell phone, and then you have all the data, and there's like self-improvement, you have like ASI, but you want to ask yourself whether you want to live in a world like that. I guess you have another thing, next, but I'll reserve some comments for later. But yeah, I really appreciate these comments.
Yeah. Anyone else who want to share some perspective on theme number 3? Because we do have some trustworthy and privacy issues in theme number 4, so just leave it for that.
I think I'm the last person. So for question 2, as you already said, I believe some external memory that is not integrated directly to the neural network could be a solution to resolve this issue. So for example, if we build very nicely organized multimodal knowledge graph, then even though some two different modalities are not directly connected, some physical perspective or physical attributes, but we can somehow make the link between these two input modalities through the already well-established multimodal knowledge graph. Yeah. And for third question, as I already mentioned multiple times, I also believe robotics or physical AI or embedded AI would be a good application that can benefit from the next generation of multimodal AI. So for example, robots with the audio input modality can immediately identify some physical geolocation that the robot must focus on. And also, personally, I think we don't have to restrict ourselves to the human sensing systems. For example, we can add LiDAR systems, as already mentioned, and also we may add hyperspectral imaging devices as another input modality to, for example, understand the materials of the objects in the scene and so on and so forth. Then such robots may perform much better than we human in certain tasks. I think such robots should be really valuable than general purpose robots.
Thank you. Thank you for your insights. Let's move on to the last theme, which is about trustworthy and real-world multimodal AI. Some questions are, what are the biggest obstacles to deploying multimodal AI safely and reliably in real-world settings, including collecting the privacy data? How should the community address robustness, interpretability, alignment, and safety as a multimodal system become more capable? And the last question is, looking ahead 5 years, which is pretty much insane these days, but what breakthroughs do you expect will have the greatest impact on multimodal AI? Can you start with the
industrial perspective? I could answer to number 1. The biggest obstacles for deploying multimodal AI is the separate systems. It is a the multimodality is being encoded by separate encoder and feed into some language model backbone and then fed into another decoder systems. It just generates some kind of latency and the complexity of the systems. So everybody is seeking a way to mix it all together into one model because of the simplicity. The complexity is just leads to a cost problem. So there is real obstacles for deploying systems. It is just a practitioner view.
Thank you.
Maybe I can say one word. I have no idea about this question, but I just thought about real world multimodal AI. When we talk about this, we talk about, assistants, robots, things like that. But one thing I'm interested in is applications of AI to sciences. And those are real world things that may have a real big impact. And I think many, many people are working on that, of course. And in that case, the data is going to be very different and not necessarily done for, it's not coming from people, it's not coming from, there's nothing to imitate. We have experiments and data from experiments. And I think we should keep this as a community. I know the big labs are thinking about that, but as a community, we should keep these issues in mind. And I think in those the multimodal thing and the new sensors and the exotic sensors will play a big role.
Yeah, the question one as a company that deals with real world problems and solving some of the many problems that visual intelligence has. I think the question can be better framed if we say, what are the biggest obstacles to deploying multimodal AI-enabled products and applications safely and reliably? Each and every product and use case presents very unique different challenges, from humanoids to even virtual agents. And I think that is something that we will all learn, how to deploy such applications and products in a good way. And also, I would say from the consumer's point of view and users, we talk about AI ethics of providing and deploying responsible, safe, trustworthy, fair, and aligned technology out into the world. I also believe that as we mature as a community, users and regulators should also have ethics on how to safely, reliably deploy and use such technologies and products for its good. For Q3, for question 3, I would say 2 things. Right now, the world of robotics is, I don't know, for the most part, I'm not an expert there, but they're predominantly consumed with control and dexterity and control of the hardware that is able to make robots and autonomous machines act effectively in the world. Then we have large language models, higher level intelligence that resides in the virtual world for the most part. So I think the main challenges are there are some layers between those 2 realms that could connect the 2 between the virtual world's intelligence to the physical world. That's an extremely exciting topic that we're very consumed with. Next is real-world requirements on latency and efficiency. Unlike language models and unlike speech systems, even in real world, I would argue that the systems of tomorrow that we call embodied agents will have to deal with laws of physics in terms of power, latency, networking. And so being able to deploy very, very performant technologies in devices that have to be mobile in certain situations is going to be quite key to it being very useful in the real world. Because if it's the smartest humanoid out there, but it takes hours and hours to do a task, or more critically, if that latency and or reliability results in risk of dangerous consequences, then that certainly has to be taken care of. So those things are some things that I think will be very, very challenging.
I want to talk about maybe the organizational and operational challenges, opportunities of building, the real-world multimodal AI. Again, for a large language model frontier lab, like for example OpenAI, you get this data for free, you happen to have this data on the internet, like people upload this data to the internet, so you get this for free and build intelligence, and you want to push this to every corner of the world to solve problems. But if you think about like building multimodal models, and there's apparently like a dilemma here. So the data's there, but without a good model, this data is kind of like useless. Again, without this data, if this data is just like proprietary and you know, like hiding somewhere, then you'll never be able to train the most kind of generalizable kind of model. So essentially, this is a very different problem than like building a large language model company, right? So I think my answer, I've been thinking about this is this has to be through a form of kind of collaboration, ecosystem, partnership, where people can actually contribute their data, and then like, you know, we can build a model kind of together, and then like this model can actually create value for the partners, and then you have this kind of flywheel, you know, going. So you can actually train better and better models, and then, you know, this model will benefit everyone in the world. I think this is actually, you know, very challenging. I don't think any company is like doing this right now, but I think we kind of have to do it to be able to really leverage all this data sources in the world.
Thank you.
Yep. Do you have anything to speak?
Actually, yeah, final thing. Actually, we are in my company. Our team is seeking an opportunity to find an opportunity in multimodal in the real-time setup. I think that the true benefit might be emerged from the real-time multimodal multi-channel setup. It might be very fascinating because it could replace CPUs at all, because all kinds of preferred devices, information flows into multimodal real-time AI and the flow out to multi-channel output, some kind of a motor or some devices. It might be very fascinating. I think that this might be, but in the academic field, I think that there are some small number of researches undergo about real-time use. So I think this might be the great opportunity for your researchers. And the number one or number two question, I'm very cautious because I'm working for the company, and everybody knows, and as mentioned earlier, safety is a very issue, and the copyright is also a very critical issue. And we would like to solve with the community and under the proper law, and we should make some kind of new laws to tackle with these new emerging problems. It's a very difficult problem, and maybe I think that there might be some inflection point, just like AlphaGo did, because AlphaGo had been tried with this under supervision setting. Under the first stage that was trained with prescribed keyboard. I don't know what is keyboard in English, but after that it had been trained with the self-play setup, and we are, as we all see, and we are saying about the world model. The world model is sort of like a self-play. We can augment the world after that. We don't need the data from internet, because all kinds of data can be simulated in the arbitrary setup, maybe arbitrary universe setup. But maybe after that, AI company doesn't need extra data from the world. That might be the inflection point I'm expecting.
I'm talk about a bit different aspect, the reliability of multimodal AI systems in real-world settings. Because my background is computer vision, I'm interested in robustness of visual perception. And we recently found that even very recent state-of-the-art vision language models or vision language action models are quite vulnerable to visual degradation. But this happens quite frequently in the real-world setting, for example, due to the adverse weather conditions or nighttime or some sensor noises. So, and also audios would be corrupted by noises very frequently, and also language prompts the BLM models or BLM models are very sensitive to the language prompt. So for a reliable use of the multimodal AI systems in the real world, I guess we have to guarantee the reliability of such models to those degradations or losses. And for the third question, I believe self-growing strategy of multimodal AI system would be a big breakthrough. So for example, here the self-growing does not mean the self-supervised learning, but I guess we may be able to build some AI systems that can collect actively, proactively the data or modality it really requires to enrich its multimodal knowledge. For example, if in the case of embodied AI system that has some body that work in the real world, physical world, then it may autonomously collect some required images of a certain object that is not directly perceived, given its knowledge. But by changing its viewpoint and zoom in and zoom out, it may find some a shot of the object that is much better perceived by the current knowledge. And then the model can learn further about the object using those images or videos that are acquired during this active navigation. Or for the other modalities, maybe the model could collect some useful training data without human intervention and maybe use those data to improve its ability automatically. So I think such a strategy would make great impact in multimodal AI in the future.
Thank you. Thank you for your insights. Now we have covered both themes that I have prepared, and it is time for the audience to be involved. So we have time for a few questions from the audience. So if you have a question, please raise your hand. Our staff member will bring you a microphone. Any question from the audience? Or the panelists who want to share some different views that you see?
Thank you for the great panel discussion. I'm very excited about the future of multimodal learning. So one key message I get from the panel discussion is that multimodal learning is very different from language. So we couldn't just transfer the rest of LM to multimodal learning. And also, like this morning, Leslie's presentation also touched on about that. She mentioned there's a trade-off between structure and data and how we can use a structure to make learning more data efficient for robotics, which I also think is true for multimodal learning because as we discussed, we also have the scarce data problem. So I'm wondering what kind of structure we could leverage for multimodal learning. And if we want to bet on data, what is the objective that we can exploit data?
Who want to answer first?
I think you should, first of all, I kind of disagree with the structure argument. I feel like we should still try to, respect the beta lesson and trying to keep the system as simple as possible. And then I'm surprised, the word model, concept has not really been come up with, in this panel. But I think, one of that is really build a scalable kind of word model, what tensor clean data that's really high dimensional and continuous and noisy. So I think this can map that. If I have to say one structure, then word model itself, I think it's kind of structure, right? Doing the form kind of next state prediction, I feel like this is a very promising paradigm, which is still kind of open research question right now.
Thank you.
Maybe I can add. To train VLM, we had to make some highly detailed caption to cycle the back translation. So the information should not be should not be there. Should be no loss for information across the modalities. Maybe that is kind of an answer for your question. I don't know. That was very helpful for our configuration, but it is just for primary, very basic level of multimodality. But for higher level multimodalities, I don't know which setup might be useful. So.
Yeah, it's a very pertinent question that every researcher in the era or the area of multimodal and world models would be like really struggling with. Maybe if we confine it to videos of the real world and not animated videos, videos represent, I think, a kind of a different language. Because right now, YouTubers, they use video to express themselves and express what they feel, what is around them. Same, I think, with egocentric videos in a different way. It is a representation in a language of the physical world that we live in. But the physical world that we live in is actually governed by the laws of physics, which is space and time. And I think space and time can have some structures if we model it really well. If you look at videos, you can, for videos of nature, you might be able to derive some structures from spatial dimensions and vectors. Also, there's a time, and time is actually something that is well understood and known. And if it's captured well and faithfully, you can also do some structuring on the temporal realms as well. That's not the only way to do it, but since you asked, I think that could be one idea you could pursue.
Thanks.
So do you mean to design the structure, or this is like, emerge the structure?
Emerge. Yeah,
totally agree.
Designing it would be kind of dumb. Yeah, I mean, in this era, you don't want to design things. You want to let others, like techniques and representations and different models, do the designing for you.
I wanted to add a word that may not have to do anything with your question, but I was just thinking. Again, I think LLMs are amazing, but whether or not, and we talked about it before, whether or not to give language a central part in the AI system, I don't know. I would argue that most animals don't have language, and yet they do pretty dang well in the world. And today we have an agent, an AI agent that works as good as a rat, as a cat, as a bird, as whatever. We're pretty happy. And again, they have some communication. Some of them have some communication devices, and I'm not a biologist, but most of them don't have language. So we can probably do, if language helps, good, but we can probably do without language as well.
Can I ask an additional question, a follow-up, if we have time?
Do we have any other? Just let me check. Do we have any other questions from other people? If not, you can go ahead. Yeah.
Thank you. Yeah, just to follow up. So if we want some structure, or we want learning some good properties emerges from learning, and we bet on data, I think for multimodal learning, alignment is very important. But what bothers me a lot is it's very hard to find perfect alignment because modalities by nature is very different. Even for vision and language, it's almost impossible to have a very detailed caption that can capture everything in the image. And I think for touch, for LiDAR, radar, it's even more difficult. So how can we collect data or design objective in addressing this challenge?
So I'm not sure to answer your question, but language as a part of your structure, we know that syntax and grammar are very poor approximations of language, but yet language is built around words and around sentences and all that. We have no idea what's in there for vision, no idea whatsoever. I hope I don't offend anyone. I'm not a neuroscientist. So aligning images and language without trying to specify ahead of time some kind of vocabulary that you decide, I think is very difficult. I don't know if it answers what you.
How about for other modalities where we have even more scarce data?
I think to be a lot the same. Again, what do I know? But there's a risk to be the same for many other modalities that there's no particular reason they should align. like videos and the soundtrack of videos, sure. But for others, not clear to me at all.
In my experience, it is the explicit parallel data across the modalities always helpful. So if you can generate some kind of data with many modalities set up, it might be very helpful. We call it LLM regime, we call it parallel corpus. Yeah, maybe parallel modality corpus might be better. Just my experience.
Thanks.
And I agree with you. So, the data, matching data across modalities sometimes raises about a lot of issues. Like, as you already mentioned, some part of the images are not matched with the corresponding sentences. So, very personally, I believe that we have to fundamentally change the model architectures. For example, we may change the architecture so that the architecture can automatically identify some semantic units of each modality input, and then matching the semantic units across different modalities only when they are semantically identical, and the others would not be matched. And of course, to do this, we may have to provide very fine-grained annotations of all the modalities of input, but that's practically impossible. So maybe the AI model should identify such semantic units and automatically make the correspondences and so on and so forth automatically during training, but it would be a bit difficult objective. But I think it would be a good direction for future multimodal AI learning.
Very quickly? Okay. We're running out of time. So I think you already answered your own question. I don't think we should try to really align, text and other modalities, especially not too early. I think this can come at the very final kind of stage. But it's really important to, just like do the modeling within the sort of union modality without considering like alignment of the text too prematurely. I think this is actually what distinguishes between, just the building a mapping system essentially from text to, maybe the visual output versus like a true understanding, capturing the dynamics of the world, and then, build an interface on top of it.
Thank you.
Right. I hope we have like more minutes, but we are running out of time, so I need to wrap up this session. So thank you again to our panelists for their valuable insights, and thank you for the audience for your participation. Please give our panelists another one round of applause. Thank you.
track E session under the theme AI for Life will begin at 3:55 p.m. Please make your way inside and take your seat. We also appreciate it if you could switch your smartphone or mobile phones to silent mode or vibrate. Thank you. Good afternoon, everyone. I am Jinyoung from Yonsei University. It is my pleasure to serve as the chair of Track E. So welcome to this session on AI for Life. So today we are pleased to welcome leading researchers and industry experts who will share their latest research and insights into how AI is transforming everyday life, such as healthcare or education or creativity. I hope today's session will provide valuable insight and inspire meaningful discussions. Please also note that this session is being live streamed on the official YouTube channels on Global AI Frontier Symposium 2026. So now let's begin with our first presentation. Please join me in welcoming Morita Jun, APAC head at Perplexity, who will deliver presentation titles, From Search to Action, the Agentic AI Shift. Please give him a warm round of applause.
Yeah, please join me in welcoming today's panelist, Nirupa Bidishigola, member of the technical staff at Humans N and incoming assistant professor at CMU. The Mika Jae-yoon Lo, founder and executive director of AI Culture Lab, and Alex Yoon, CEO of APAC, and Jinyoung Park, professor at Sungkyunkwan University. So please give them a warm round of applause. Hi again. So thank you for being together here. So let's get started. So let me lead my smartphone to make sure to ask them accurately. The round question 1. Looking ahead 5 years, what change are you personally trying to bring about through AI? So let me use this question as a substitute for the introduction, your self-instructions. Each of you is building and deploying and researching AI in different domains. So when you think about the next 5 years, what kind of change in the world are you hoping to create? So feel free to answer in your personal perspective or your field. You can start. Yeah.
Okay. Hi. So this is an interesting question because I'm both in the industry and in academia. And the way that I see things is from the industry standpoint, you know, I have colleagues and friends and everyone is concerned about AI replacing people and, you know, taking people's jobs or also taking away their cognitive abilities because we're becoming lazier as we rely more on AI. And then on the other hand, I have grad students and PhD students who ask me, what should we do if AI is going to take our jobs? What should we be learning right now? What should we be focusing on? And also, you know, all the labs are doing the work that is more compute intensive. And then what should we be doing? And I think what worries me most and what I hope to be able to do is to, one, make sure that there are tasks that humans still enjoy doing, and they do as, you know, the same way that when you want to grow muscle, you have to put your body under pressure and there's time under strain. Like, you know, you don't just like lift something, you just have to like lift it slowly. And I think it's important to incorporate that in our use of AI. So instead of AI feeding you the response and not letting you sit with uncertainty and grow your mental muscle, how can we build technology that does do that? Like, you know, AI tutoring, AI for education, or even if people, because we can't keep telling people not to use AI as therapists. People are going to tell it's cheaper, it's more accessible. So how can we build a model that lets people be people and, you know, does not, I think a lot of us are changing a lot by AI. Like instead of, a lot of times when I'm working with Claude Code, I feel like Claude is directing me rather than me directing Claude, especially if you've planned anything with it. It's like, yeah, you're right, you know, I'm going to do what you said. So that is one thing, is I really want to keep thinking about human flourishing and how we can build technology and models that takes that into account and lets us be better humans.
Okay, thank you for having me today. My name is Mika. I think AI will transform creativity and culture more than anything else. Many people talk about the healthcare and education. Of course, that's very important issue, but culture is changing more than even faster, and people are not prepared fully. So, for example, through my work, I have seen many times like this. Like, for example, like AI generate images through multiple images on online. But that online, because AI is based in LLM system, so it's, and also Western information. So like online information, images, and popular artworks and famous artworks, they consume that. And so AI only generates and reproducing same version of Korea culture. So always the minor, the real culture in detail, delicate thing removed. So my interest towards, I hope in 5 years, in terms of AI, I want to build real fair system, fair image towards cultural governance, because so far the AI system is just focusing on major information. So always the images comes from Western society. So AI is not simply representing the real world. It's just to generate and reproducing the same version of concept. So I hope in terms of making the cultural governance, I want to build ecosystem to represent in fair way.
Hi, my name is Alex Changhee. I'm a CEO of EverX. Our company mission is bringing personalized rehabilitation accessible to everyone. And my background is I'm an orthopedic surgeon. And I founded this company because there are a lot of musculoskeletal patients who needs kind of home rehabilitation, but they're not getting the proper rehab because the medical resource is very limited. Physical therapist is one of the most limited medical professional in the world. And there are like average 4 to 6 weeks of waiting list in America, in Europe, in terms of to meet with the physical therapist, especially in the rural area. I mean, that's quite bad. So home rehabilitation is somewhat very required, and self-rehabilitation very required for those musculoskeletal patients to get better, because 1/3 of general population actually has musculoskeletal disorder, some sort of musculoskeletal disorder diagnosed, and because of this aging population, it's getting worse and worse. So we're trying to solve this problem with technology, and I think AI can do a lot of things in terms of bringing personalized rehabilitation accessible to everyone. So when I mean personalized rehabilitation, what do you think is the best kind of a rehabilitation that a person can get? Yeah. When you think of a professional athlete, what they're getting is probably the best kind of a rehabilitation that a person can get right now that we can think of. So a very professional rehabilitation specialist, 24/7, be there right by them, and they make them engage into the rehab every day, very personalized, like kind of being a mentor for their emotionally and physically during their rehabilitation course of treatment. Yeah, that's what kind of a personalized best rehabilitation looks like. But sadly, that's only for very successful professional athletes they can get. And in real world, it's very hard for us to do that. So what I think in 5 years, maybe it may not be the 5 years, maybe 10 years, but I'm pretty definitely sure that in the future, what I can imagine is that a personalized humanoid robot can be the therapist and actually give the exact guidance of a very professional rehabilitation specialist are giving by analyzing their movement through the vision AI, as well as giving the best protocol that those person is personally should be given. So that's kind of a world that I think is going to happen, and I would like to achieve as our company mission and be a leading company to make it happen.
Great. Okay, thanks. My name is Jinyoung. I'm an associate professor at Changhee University. So Before I answering the question, so I briefly, I mean, when I think about the question, then actually, so maybe predicting the future, it means that that one can be done when we think about the past. So that's the reason. In 5 years later, then maybe let's come back to the 5 years before. So in my experience, I'm actually the NLP guy, so that's the reason I'm focusing on the natural language processing. And then before the LLM, so I saw that there is a good conversation model, which is named Mina, and then the PALM, which is also made by the Google researchers. And one of the interesting is that at that time, only those people who are in the company can use that kind of the language model, and then that one kind of works well. But now, everyone can use LLM, right? Such as GPT and other kinds of things. So, like the Alexa's opinions, I believe that in the future, so all of the people can use AI. So not only focus on the specific services, but also the other kinds of things together with AI. Then many people can use that one. So then, based on my research interest, I'm interested in the responsible AI. So I want to, actually, especially which is related to the Mika's the opinion. So I'm thinking that the diversity itself is very important. But unfortunately, when we meet the GPT and then other kind of LLM models, the generated response is not, for me, I think it's not diverse. One of the interesting examples is actually broadcast in last week. One of the Korean broadcast system, the broadcast one of the program named one of the shortage of the LLM. When you use LLM and then discuss about the topics or then want to get some response, then usually they provide the positive feedback, right? So because maybe, so when you think about when you get the negative feedback, then maybe there are some negative effects. So that's the reason I think the companies wants to train the LLM to generate the positive feedback. But those kind of positive feedback can also make some side effects. That's because one of the examples is the user wants to make a startup company, and that's the reason he actually have a conversation with the AI, and then the AI always said, oh, you can do it. So that's a very good idea. That's a good item. But as you know, that the startup company is not easy, right? So that's the reason in my perspective. So I want to give the more diversity. I want to give the more diversities into LLM. And then one of the approaches in my laboratory is that aligning the human values. The reason is that each human has their own human value, and then that human value itself is highly related to the opinions, and the diverse opinions, and their own personal opinions and minds. So then when we align this kind of the values into LLM, then maybe the LLM can generate a diverse response, and then that kind of diversity can help to the human. So for the first question, what I wanted to say is that everyone use AI, and then that means that there are some kind of side effects when using this kind of thing, and then I wanted to prohibit this kind of the bad things. That's my answer for the question.
Yeah, thank you for all of your answers and introduction. So we now have a very amazing panelists from very different areas. So let's move on to the second questions. The question 2 is that what will AI for everyday life actually look like? So we often talk about what AI can do at the frontier, but how does AI actually diffuse into society? How will it reach ordinary peoples? Or how quickly will it spread? Or who will benefit first? So will AI narrow existing inequalities or widen them? Or the frontiers or lived realities are often very different stories. So what will AI for everyday life actually look like? So who can answer first? Be the scholar?
I think the AI will become more than a tool, and AI will be daily infrastructure. So in my and AI AI will be more invisible because it will be everywhere. In my recent book, Curating Intelligence, I argue that AI will be reshape the way how we work and how we create and how we think. But if we making the governance in a fair way, good governance, if we make good governance to guard on the AI, it will be strengthen democracy and will develop and improve cultural diversity. But if we have weak governance, it will threaten reinforce in equality and just forcing to have power. So I think the future is not only artificial intelligence, but also institutional intelligence to govern the AI to make the real ecosystem, real governance, enhance cultural diversity, and improve the public life. Thank you.
Anyone who can add?
So people usually paint a very extreme picture when they try to paint a picture of what happens when you have AI diffusion. One is the machines of loving grace of, Dario Amodei, like, oh, everything is good, it's so nice. And then there's this other picture of we're all doomed, we're going to go extinct. And what I think is it's going to be, it's kind of obvious, there's going to be something in the middle. So there's this thing in that economics called the messy middle. And this is what has happened every time there was a disruptive technology, from printing press to telephone centers to all of that. It takes a long time for the technology to trickle through the society and then impact different people's lives. And so what I think will happen with AI, and it's not necessarily something I like or don't like, is for richer societies, it will probably be nice, right? You get to do more, things are good, but there is definitely this richer becomes richer situation because tokens are expensive, and then you use more tokens, and then you produce more so you can make more money and then use more tokens. But then thinking of countries that are third world that can't afford to use these tools, that don't have deployment, or the languages are not covered, they're gonna, this disparity is just going to grow. So that's one thing. The other thing that I worry about is the obliteration of some cultures. I think cultures that not even like with languages, it's not like low resource languages. I think language and culture are different things. And then you can have mid-resource languages and mid-resource cultures that get eroded. So I'm Iranian. And then my friends use ChatGPT to throw a surprise birthday party for me. And I was like, oh, that's really nice. And they're not Iranians. And then they brought out the cake, and the cake had no candles. And I was like, okay, guys, thank you. This is nice. You run out of your rage. You got me a cake, but where are the candles? And they said, oh, ChatGPT said, like, Iranians don't use candles. It's bad luck. And there's no such thing. And this has happened a lot in my relationships with my non-Iranian friends. And I'm a very sarcastic person. So I say something, and they don't believe me, and they believe ChatGPT over me. And this worries me because as this happens more and more in society, some cultures, and Iran is not like a low resource, it's not a small culture. So if this is happening to a culture that is not even underrepresented, then more bad things are going to happen to other cultures. So these are the things that I do worry about as people rely more on AI. Sorry.
I kind of agree on what you said, and that's because I think worldwide the productivity as of now is not little. I think the productivity for food is enough to feed everyone in the world, but still there are poor who cannot eat. So AI is going to make a lot of things efficient and more productive, but it will eventually, if it's not governed well, I think it will eventually lead to more disparity between poor and rich and country to country So that's something I think very worrisome. AI will dominantly, I think, used in rich countries for rich people and make their productivity get better. But government has to, I think, have a very good way of controlling them in order to make it actually benefit everyone.
Yeah, so, okay, all right. So then my question, my answer for the question, original question is that, well, actually the last year I also participated in this kind of panel discussion. And then at that time, the question is quite similar. And then my answer is that, let's imagine that, so the question itself is that in the future, so does AI destroy the human civilization or not? Some kind of pessimistic one. And then my answer is like that. One of the interesting story, imagination story is that when we meet alien, for instance, when we imagine that when we meet alien, then do they also destroy the human civilization or not? And then one of the interesting answers is that no. The reason is that if the alien is too smart to come to us, right, from their home, then maybe so the technologically and then smartness itself is much higher than human beings. So then maybe so they already know the ethical ones and other things. For instance, the human can protect the animals, right? So then that kind of things are maybe coming from the human's own ethical mind, the behavior. Then the alien can do that, which is same procedure, same the reasoning. And we can replace the alien into maybe the artificial superintelligence or whatever when we meet this kind of good, the higher intelligence one. So that's the reason whenever I think about the future, about the pessimistic and optimistic, I also really believe. So maybe that's the middle in the middle between them, right? But then, and then whenever I say about for the pessimistic person, I just give the example like that. So that's my answer for the original question. And I also so maybe I might ask about, that's a panel discussion, right? Even though there is a moderator, maybe I can also ask something. And then especially for you, so you mentioned that the culture is different to language. And I totally and definitely agree with you. But the problem is that whenever we think about the language itself, then it's much convenient, it's much easy to define. There's English, there's Korean, things like that. But the culture, wow, that's harder to define, right? Maybe the country itself is one of the cultural one. And then each generation, they have their own cultural things. So then when we have to think about this kind of the cultural thing, which is related to AI and then other things, then what's your opinion to define the culture? So I'm just curious about this one. And then also the other panels, I also maybe if you have an answer for that one, then I'm very happy to listen to your opinion and comments.
Mm-hmm. That's a really good question. I think there are two ways you can look at it. One is a pragmatist way of, I want to preserve the culture. How do we do it? And if we accept that AI is going to be a form of a language model, the way we have language models these days, what this means is that we have to put everything about culture into words and we have to describe it. And I remember in 2023, 2024, when ChatGPT was first out and it was really bad at theory of mind and common sense reasoning, people were like, yeah, Yejin had this line of it's dark matter, right? We don't write about it, therefore, then it's not rich and then it's not in the language model. And then people were saying, okay, we can't have someone sit down and write everything. But that is kind of where we landed, right? There are all these, for how models got better at math was because we have math experts sitting down annotating. So data has become very expensive, annotations are expensive. So from a pragmatist way, if we accept that language models are the way we are going to go, then we really need someone to go sit down and write down everything about every culture and make sure it's preserved. And that is if you're scaling law LLM build. But there is this other thing that you can't really do this for robotics and for vision and for everything. And if we have another paradigm, then these are embodied experiences, right? Culture is an embodied experience. Physical world is an embodied experience. And then maybe we do need to have a model that can capture the omnipresent, capture everything about an embodied experience. And then how do we do that? I don't really know. Yeah, I think that's a great question.
Thank you for the answers. I'm not pushing to answer my question, so don't worry about it.
I mean, no, actually,
You have to answer it. Yeah, you can.
yeah, because you have the AI cultural lab, right? So you probably.
I think it reminds me of the news you might know this year, February, I think. One of the biggest museum, British Museum in UK, they posted some images that represents Asian in front of Asian artifacts. So their intention was to show Korean, Japanese, Chinese audience to see the artifacts, but they just generate through the Nano Banana, the Gemini. So the Gemini mixed Japanese and Korean, Chinese the costume because they don't have any idea. They don't have any idea because it's LLM system. So Western society they couldn't, very difficult to differentiate Korean, Japanese, and China. So they just mixed that. So for us, it was very weird costume. So the audience, the Asian audience attack, this is not ours. So they just removed that post. So it means
maybe that's the Oriental culture, isn't it?
yes, but LLM system there's some misunderstood because all information just mainly Western societies. So not only language, if we just pile up and make AI to consume the images in detail, they could differentiate. But so one thing I have seen in meaningful way recently, the South to South outside from Western society like U.S., European countries, Asians, South Africans, and South American society started to discuss and collect the to be represent more to have many openly conference and events. So it's very meaningful start, I think.
Yeah, talking about culture. So I think the unique culture difference between countries or region come actually from the ability of a human to actually connect. So before, because it was, the transportation was bad and the internet wasn't existing, so they were very localized societies and they had their unique culture. But as this transportation gets better, as the internet kind of allows for everyone to see other countries, I think the mixture of culture happens naturally. And just as K-pop is now emerging in the United States or other countries in the world, this kind of a cultural, I think, mingling would happen more and more in the future. And I think AI would just facilitate them more and more in the future. So what I kind of imagine in the long term wise in the future is that the difference between countries and between the continents maybe would be much lesser than now because real-time translation of language would be available. You can actually see all of the cultures and actual real-time like sites of those locations anywhere in the world. VR can show that anytime in the world, and those kind of your experience-wise would be somewhat very different than what we had before. So those cultural difference would be very little by little in the future. That's what I kind of imagine. Yeah.
Interesting point. Yeah, that's right. So listen to the Twitter or the X, released the automatically translated in that one, and then someone said that they are fighting. Each country images are fighting each other because they can't communicate. But anyway, it means that they have a communication much easier than before because of the AI. And then maybe one of the worries, and then that's my also mentioned in the previous one, is that it's monetizing into maybe, one of the limitations of the globalization, right? So when we talk about the globalization, then one of the limitation is that maybe there are only few things are surviving and the others are dismissing. And then that's also things happen in the culture things together. So that's one of the worries. And then, I'm always saying that we need to fight to mitigate this kind of the limitation. Yeah, that's my answer.
Yeah, thank you for your insightful answers and discussions. So the next question is something different questions. Does AI replace human capabilities or amplify them? So as AI becomes increasingly capable, where do humans fit into the future? So will AI ultimately substitute for human expertise or augment it? So for example, if AI becomes superhuman at tasks such as research, will society still value and reward human researchers? Perhaps not because humans are faster, but because we still rely on human judgment, accountability, or taste, or ability to decide which questions are worth asking on the first place. So does AI replace the human capability or amplify them?
Well, I used to think, there are some portion that humans are only capable of. I used to think that way. Now I get to think more like, that portion is very little. Maybe a lot of humans' capability would be somewhat replaced by humanoid robots or AI features. And for example, like empathy, giving empathy. It's something that we used to think that's kind of a only thing that human can do, but that's not actually true as we experience that, actually, in Korea, the elderly population in suburban rural area, there are a lot of elder population who lives alone, and there used to be humans who visit their home regularly to check if they're okay, be their buddy, and now what actually those public health systems have implemented was calling AI agent. So now those AI agents call those solo living elder population, and they're having a regular conversation with those population. And what we see is that those AI agents are so good at those conversations. They remember everything those elder populations say, and they ask about their children, how they're doing, their daily life, and they remember everything, the context and everything. So they feel very empathetic, and so that when real human visits them, they ask for those AI agents because they think that that person is much better. That's what is happening. So I think in a lot of ways, what we thought human can only do, like making music, artistic things, those things we thought this is something that maybe AI cannot do. But now we get to realize that, okay, AI can make very good music, AI can paint very well. Those kind of things evolve. So now I get to think that there are very little things maybe AI cannot do, so what I get to think is that because humans need to have something to do, it's not like you can live happy life without doing anything. That's just a miserable life. So now I get to think that we need to maybe protect something that from AI to do those things that maybe humans don't want to do, and what the things that humans want to do, we just have to protect ourselves from AI to do taking place on that. That's kind of a recent thought that I'm having. Yeah.
Interesting. Yeah. So regarding to the memorization, so in my experience, so when I was a child, so I can memorize my parents' phone number and my phone number and my friend's phone number, but now, I don't need to do it. maybe I can only memorize my phone number because, so it's easy to call by the phone by just asking, hey, I just wanted to call to my mom. But anyway, so for the question, for the answering for the original question, so I can definitely say that one word, the evolution. So, so when you think about the evolutions in human species, then the evolution is coming in the history and then up until now. And then that's what I believe. So that means that if the AI is much higher, much smarter, then the human can also evolve and follow this kind of thing. I know that the speed itself is quite different. So that could be the problem, but maybe that will be possible because the next generation can learn the different things. Well, that's because that's also coming from my personal experience. When I was the elementary school student, I tested a math, and then the elementary school math test is quite easy, right? Just the summation of the 10 digits all together. And then I'm wrong. It's wrong. So my answer is wrong. So that's the reason my mother said that, how could you do this? So the computation, the summation itself is quite easy. So, but why did you do that? Then for that kind of claim, my answer is that, calculator can work quite well. Why do I need to train this kind of the action? That's my answer. And then I'm still thinking about that one. So what I wanted to say is that maybe in the next generation, and all the now, teenagers or much younger people, they don't want to memorize the phone number, or they don't want to train on the summation and other things, but they might learn the different things with AI. Then it also will amplify the human's smartness and other things, other abilities. So that's my answer for the original question.
I've been thinking a lot about this question, maybe partially as a form of an existential threat to my own cognitive power, because the more, again, I use Claude, the more I feel like, all the things that I thought only I could do as a researcher, it's doing. So what am I supposed to do? And there's different ways that you cope with it. I have empathy. Grad students, they're different, they're fun. It's different from working with Claude, and that is true. But I think part of what I don't like about the framing of will AI take people's jobs is the lack of agency for us. It's like predict if AI will do this or not. I think it's more, will we let it do this or not, and keep creating new jobs? So I'm not saying that we should not automate things and let humans do it. I think there is a world in which we could become very apathetic and let go, and things happen, like things are automated, there's food, and you can just watch Netflix all day, every day, and that can be your life. And I think we might not be too far from reaching a level of automation and abundance where everyone can just have this type of life if we crack embodied agents and robotics, and they can also do stuff. Then a lot of people can just probably sit back and watch TV all day. But is that something we want? Like, people like purpose. And so how can we create more cognitively enticing jobs, or how can we make sure that there is still room for intellectual pursuit? And I think we have to just remain curious to create those jobs that we don't know what they are. I think in the 1600s or before that, there was this job called a knucker upper. So it's this person that goes with a stick and knocks on people's doors and wakes them up in the morning because there are no alarm clocks. And I feel like if I was a person from then, I would never imagine life without a knucker upper, right? Because how am I going to wake up, and how can you automate that? But it just the job disappeared in a span of a few months so I think, maybe our jobs, someday someone is going to look like, there used to be software engineers, and that's so weird. But I think it's on us to keep thinking of what is valuable. And I think there will, I can see the empathy thing, that models are really good at empathy, but I feel like there is something about exclusivity, in art, a print versus the actual painting. There's something about the uniqueness of the, artisan type of things that we have. And I think people might still want unique or exclusive experiences that you can make special with humans or make unique. I think everything about AI is very reproducible, but with humans, things are not as reproducible, if that makes sense. So I don't know. I'm just trying to cope. Yeah.
Okay, I think for this question, I think it depends on how we govern AI. For example, like AI could replace artist job, and also AI could have the small galleries to represent all around the world. It's the same AI model, but the difference is governance. Who control the trust data, and who gives the consent, and who take a responsibility? That's not technology issue. That's the governance issue. So I think to build real governance is most important thing in terms of AI. So like this, AI doesn't people amplify and replace itself. The governance will be defined and will be control this situation. But through the panel talking, I feel like so then what human has to do, right? What human has to do. You might read the news article 6-8 months ago, Japanese girl got married with AI, right? That was very shocked for some people, but it could be common. I don't know. It could be common, right? So in terms of empathy, the AI give more empathy towards the old people, right? So I don't know what is humanity, what is human, and what human has to do instead of AI. Like 1 year ago, like most of people talk about the main difference between human and AI is the body and physical, but physical AI now already done. So empathy also same. Of course, still there is some errors to communicate between AI, but if we in terms of developing the technology, it could be follow up the makeup. So when it comes to talk about the AI, I always have questioned what is human, what's the difference between AI and human, and what we should conserve and preserve as a human. I don't know. I don't have any idea. Thank you.
What I think that AI cannot have is they cannot own something. Yeah, they cannot own material. They cannot own responsibility. So that has to come from human. That's what I think. Yeah. So that part of work is something should be always be human. You cannot blame AI and you cannot put AI into jail if they fail something. Yeah. So that part is human.
Why can you not do it? I mean, once you have the regulation in place, it can own things and you can. I'm being the devil's advocate, but yeah, like you can put it actually in jail. Why not? Let's say that like I have an AI. Actually, if we were to deploy a very Western US-based thing where you don't have regulations for anything and you just let things go until something bad happens. Let's say that like everyone in the US, like they have an Optimus Prime, like a robot that does things and you're in charge, like you're liable if it does something. And then if it actually does something bad, they'll put it in jail and then you have to do everything yourself. Imagine having to write code again yourself. So, and then that will, you know, motivate people to make sure that their like AIs is good, like regulated well. Otherwise, they won't send it out. Again, just an hypothetical, but you could. Sorry, no, I didn't. This is not. I feel you.
I mean, yeah, let's say, yeah, let's say an AI robot killed a man.
Yeah.
Killed a man. And there should be something wrong with that robot to do that. Or there should be a human who made this robot can do that. So when you are a victim of that kind of crime, then you wouldn't let those robots to be going to jail. Who's responsible for that robot to do that would go to jail is something that naturally going to be a course of thinking, I think.
Yeah, but I worry that like as we have things proliferate, then for me, even if I don't go to jail, but my robot goes to jail, like if I depend on it so much for everyday tasks, it would be as bad. So I'm same way that I'm incentivized to not murder someone, like I would feel responsible for my AI to not do it. It's just like delegation of responsibility. But I mean, I agree, this is a very far world and I don't think it will happen, but you cannot, it's sad.
That's right. I also agree, actually, but I also agree with Alex's opinions, especially the difference between the AI and the human is the human has something own something, right? And then, but I'm just curious, and then, in my opinion, so the own something, the what's something, and then my answer for that one is, as I mentioned, the value. So when you think about the value, then it means that that's the importance of something, right? So for instance, someone believes that the security is important, and while someone believes that life itself is very important, right? Then maybe that kind of the importance, which is born, the value itself is naturally born. I don't know, how can they generate for each human? So then maybe that's the one of the difference, and then if AI somehow think this kind of the value systems or values, which is naturally born, and then maybe we can give some kind of responsibilities. Yeah, we can destroy the robot if they are doing wrong. But up until now, so that kind of value stuff is coming from the human. So that's my opinion. But I don't know. So that's also one of the big considerations and questions. Yeah. Anyways, thank you. Thank you for the good points.
Thank you for all your answers. So the next question. If AI can answer almost anything, everything, what should it teach the next generations, like a newborn and when they are kids? So what becomes the purpose of education when knowledge and expertise are instantly accessible? So should it place greater emphasis on asking good questions or judgment, creativity, collaborations, or the ability to navigate uncertainty? So what skills will become more important or not less, in the age of AI? As AI becomes more capable, what is the most important human capabilities to preserve? What value, habits of mind, or ways of thinking should remain fundamentally humans regardless of how advanced AI becomes?
So after getting this question, I'm married and I have 3 kids, and I get to think it every day. What should I teach them? And I asked a lot of people about this too, because this world is changing so fast, and you don't know that the education that I got would be somewhat beneficial to our kids or not, and that's kind of a very, I think, difficult question. And one of our wise mentor of me, myself, shared me his thought that with this changing kind of environment, your kids will grow well. You have to adopt. You will be the one who may be having a problem adapting to this kind of a fast-changing world. The young kids would just do that fine. Maybe that's fine. But going back to what we should value to our next generation is that, because I believe that human still is going to be the one who's owning the material and owning the responsibility and making the decision for that material and the responsibility. I think you have to make a next generation, the most important thing they need to have is their charm, originality, charm. I think that's very important. And that has to come from their kind of experience. So making them experience various things throughout their course of life is very, I think, important. And maybe the product of AI, what AI makes, maybe would be fascinating, maybe would be somewhat touching, but I don't think that human will be moved by what AI is doing. Yeah, let's say robot just climbed Mount Everest. Is that moving, touching? No. Human would not be fascinated by something that AI or robots do, but human would be still very fascinated by what humans do. What humans have achieved through their life, the story of it, the experience, that should be the something that's going to be very important in the future. And I think that has to come from the experience. So various experience is something that we need our next generation to have. Is something.
I want to add Alex's comments. I heard often from young generation, young people, why I should learn something, because already AI can do better. But I think it's the wrong way to see the AI. As Alex mentioned, your experience, your value is unique, right? So experience is most important thing as a human. But I'm not sure, because it could be followed up by AI someday. But still, as a human, it's very unique experience. It's my thing, my experience. Your experience is different. So that's why we touch some parts, but we cannot empathy toward another something, because I don't have any experience toward that. So my unique experience, my unique taste is most important thing. And also through the panel talk, the difference between AI and human could be own something and take a responsibility. Like taking responsibility also important thing to teach, if I could, towards next generation, because I don't know, developing the technology, we sometimes very difficult to differentiate reality and virtual thing. And also in terms of the art scene, recently AI art and virtual art is more popular because we want to see something new and more interact and more sparkling something. But as you mentioned, when we saw the real artworks, real touch, real brush, we could touch more than virtual, distant, generative image. So I don't know, through the panel talk, I'm thinking again and again, what's the human and what's the different what's the difference between AI and human, and what should I keep something as a human. But taking responsibility and having a good question and making my own unique experience could be meaningful, I think.
Yeah, I've thought about this a lot, and the conclusion I came to is we shouldn't change anything. No, the thing is, if you think about it, how has schooling and human values changed? How has the way people raise their kids changed from even 1600s? The math is still the same. We have calculators, but we still teach kids the same math. We still teach them the same literature. The basics are the same, and we do the teaching. So I think there's a sense of utilitarianism in things we do. And once you take that away, then the whole purpose of the education is for the human experience and for growth. And again, we either give into this reality where we just don't do anything ever, which is one way of doing it, or we just continue doing things the way they are, because that's the human experience and that's what has worked. And I think, like, as you guys were talking about the Everest and the mountain, and as I was thinking, I think what makes it different, like why people still like watching people play soccer or people play chess or climb a mountain, is the unpredictability, because you don't know if the human will actually make it or like who will win, and you really don't know it until it ends. But when a model or a robot is programmed to do something, it'll do it like with almost all certainty. And then if it doesn't make it, like even if you send a robot and it's going up and it falls off, like no one will really care that much. And I think maybe through generations, there is a world in which robots are maybe like people's pets, and then they care about them, and then that's a whole different bonding experience that I can't reason about. But I personally hope that human values stay the same, and we still value curiosity and just, questioning all the premises, which I think should have been a value from before, but now with AI, kind of, if I'm teaching people, I want them to question every premise and be ready for things to change.
Okay, so for the answering the original questions, and then I think we can just distinguish the two parts. The first one is the skill, and the second one is the other things. So, but in terms of the skills, well, I also think about three things, and then so those three things. The first one is it's also coming from my personal one. So when I was a child, and then so there is some tool named in Korean Jupan, and then that's a udon, and then the marbles, and then that's a kind of calculator to help calculate the summation and the minus or something like that, something like that. But unfortunately, I don't know how to use it, even though I've seen that one in my house and in the school, because I don't have any time to learn about this one. But then the reason is that we can use calculator computers to do these kind of things. And the second thing is I wanted to say is that I've seen that one in the apocalypse movie, and then the apocalypse means that everything's destroyed, right? Maybe the nuclear bomb or whatever, the zombie, right? But one person's and I started that. So in a past time, the children learned how to distinguish whether this machine is good or bad. That's the countryside part, and then every children can learn these kind of things. Maybe this girl can eat or not, and if this fish is good for eating or not, that kind of things I teach. However, recently, in the modern generations, that's not taught in the school, right, or in the home. But is it a problem now? I think it's an apocalypse case is a problem, but now it's not. And then the third thing, that's also interesting. So about 100 or 150 years ago, when I have seen the entrance exam to enter the MIT and Harvard, and then that's a math exam. And then the hardness and the complexity of the math problem itself is now that kind of things are taught in the middle school. So I wanted to say that 100 years ago, when I wanted to enter the university, then nowadays the middle school there itself is required, right? So that's the reason. When I summarize these things together, what I wanted to say is that the problems are changed, right? Even though the AI is coming and whatever is coming, so then it means that the AI can also help to solve the more complicated, more hard problem. Then younger generations can do better work. That's also, I also agree with Alex's opinion, the other opinions. Yeah. So actually, so I don't have any worries about the younger generation. They can do, I know that I'm not married and I don't have any children, so that's the reason I'm thinking about like that. Maybe after that, so if I have a children, then maybe I might change the mind, but that's the one thing. And then what should we keep as a values and all the kind of things? Where then if I have a child, then I might teach some kind of philosophical the question. There are some kind of ancient philosophical questions. So then that quote is coming from Descartes, and then so I'm thinking, so now I exist. I don't know about that one exactly, which is translated in English, but because I've learned about it in Korean. But anyway, what I wanted to say is that, so each human or each person should think about who am I as a human being, and who am I, who others are, and then we need to respect ourselves, and myself, and ourselves, and then others. Yeah, that kind of the philosophical and ethical one should keep, and then should teach. And others, as I mentioned, kind of skillful things and other things. Yeah, with the AI and the whatever, then younger generations can do very well. So that's my answer and my opinion about this one. And I'm just curious about your opinion for my thing.
Thank you, thank you. All of your answers are very interesting and insightful and even informative. So we now have time for a few questions from the audience. So if you have questions, please raise your hand.
Well, actually, I have a question. So when you talk about the last question in this session, and also, in the morning section, the Kim mentioned and asked the question to the panelists as what's the comments to the younger generations if we meet AI in the future, right? And then, but one of the worry, in my opinion, one of the worry things is that younger generations, as I mentioned, they can do very well because they are young, they can adopt the AI very well and then very fast. But elderly people or someone who are not familiar with this, or as Nihon mentioned that, so what's that, the low resource countries, people and other things, maybe they are fighting with AI, which is much harder than the younger generation. So then what should we say or do for them, not the younger generation only? Or do they do the same strategy or the methodologies to younger generation and then those people together, or what should we distinguish? I'm just curious, and the questions for the panelists too. And then as a panel, maybe I need to say my answer first, and then maybe you have a time to think about your answer, right? I know that's a quite writing question. For me, yes, so I think we need to distinguish the strategy to the younger generation and then the others and then people and other things. But the reason I bring this question is that still I don't know about how to do that, because many people are saying about the younger generations like this, but not the elder people and then the others. And then, as Alex mentioned, so that there is examples of the elder people get the empathy from the AI, and then there could be some problem. Then how can we mitigate? Yeah, I mean, so I know that's not a good answer for the question. So, but I'm just curious about your opinion. So, please, if you have any ideas or the comments, then I'm willing to listen to your opinion.
It's very unique and interesting question. But like for older people and very lack of technology to follow up young generation, I think that's not the answer. Just follow up and learn same level of technology changes. Like if I think of art, like when it comes to talking with artists, I feel free and interesting and very exciting since they have different words. Yeah, that's the cultural diversity. So when I talk about with artists, I feel like travel. So like just if we follow up same level, same version of technology and AI, especially AI, we should be the same. Like in terms of strategy, I don't know, like maybe the strategic way just to be me, just to be myself. But it could it sounds like ironic because we talk about the AI and AI give many opportunity to people, but at the same time, still one of the most worst thing is to remove the diversity. So for young generation who lives in lack of technology, I want to advise them no need to follow up all technology, just to build your words, build your unique experience.
I have a very similar opinion on that. So these technologies doesn't make human happy at all. And we know that. We're even removing cell phone from kids right now because that's not making them happy at all. Yeah. So we don't need to educate this new technology to the ones who are not in contact with that. So we can. I think we need to. What we need to do is that protect them from getting violenced by the ones who use that technology. It's something that we need to make effort on, but we don't need to.
Yeah, something similar and also touch grass. I think in an era where we have abundance, it's important to remember that you now have the privilege of figuring out what brings you joy without having to have this existential threat of, oh, like, am I going to be fed? Am I going to, stuff going to be done? And I think a lot of times people lose sight of what gives them joy because they're looking at other people finding their joy. So a lot of people actually know what makes them happy, but then people around them are doing other things, and they're like, oh, this person is like doing this art thing, this person is vibe coding 5 apps every day, this person is doing this, and maybe I should be doing something similar. And Emerson has this essay called Self-Reliance, and in it there's this line that says, imitation is suicide. And I think that's the most profound thing ever, that you should just be yourself and find what yourself likes and just do that. And that could be anything, and it's not what makes other people happy. And I think, again, with AI, that's more because there's just this culture of, oh my God, I should use AI to build this thing. Everyone is building something, and I should be building 10 things, or I'm not good. Yeah, just if being in nature makes you happy, just go be in nature and touch grass. Yes.
Thank you. So, thank you to our, if you have questions, keep him.
Thank you for the nice talk and discussion. I have a question about, so at the moment, so we are only focusing on AIs on a technological part, but in the AI for life, or in the cases, we may imagine that like a watch, in that cases, the old watch is the same, but what is the emotional appeal in the AI system? So in the cases 5 years later or 10 years later, in the cases, some people buy the watch more than $1 million or something like that, and even though the functionality is same. So I cannot imagine what is the emotional appeal in the AI system. So what do you think about some, maybe, even though in the same, but if we have the same kind of the functionality in some advanced AI technique, in that cases, what can be the emotional appeal in the system?
This is what happened with GPT-4o, right? And then when they pulled it, everyone got really, really sad. Remember, like, OpenAI pulled GPT-4o, and then people were so emotionally attached to it. And there was this, I think there are many different ways that people can emotionally connect and have this endowment feeling of, oh my God, this is like my thing, and now you're taking it away. And it has already happened once, so.
It's kind of the persona, or it's a kind of the like that,
I think,
or style, or.
Yeah, maybe it's the style that it responds. It could actually be very different because with 4.0, I think it was the sycophancy that some people like. But even the 2 weeks that Fable was pulled, a lot of AI tech pros were like, oh my God, like, you know, Fable 5 is, it was so weird for me to watch. And people were so sad because they just don't have as good of an AI anymore. And then now that it's back, everyone is so happy. Oh yes, like we're going to build again. And I think here it's people think that it's this intellectual thing that was taken away from them. I don't know. I think different people can bond with different things differently. And or again, if you have people attached to Waymos in San Francisco, they really like the experience. And I don't really understand the appeal, but I think each person has something that they like and they find in a thing and they get attached to it.
Well, that's an interesting question. So you mentioned the watch as an example, right? So that's the reason, simply maybe the brand, right? Yeah. So there is a brand A is AI, brand B is AI, brand C is AI, something like that. So maybe the people prefer the first one rather than the last one. Then maybe the price of the brand AI is much higher than the brand C, even though the functionalities are the same, right? So that's also interesting. And then, well, it is hard to answer for your question, but one thing I wanted to raise the question is that, we are thinking about the AI and ethics, something like that, then the discrimination from the AI, discrimination to the human is prohibited, right? But maybe in the future, discrimination to the AI could be also prohibited. I think, yeah, maybe. I mean, I'm just wanting to say about it. So there's no, it's not an answer for your question, but maybe I wanted to raise the different questions which we wanted to discuss more.
Do you have another questions? Okay. Thank you to all of our panelists for sharing their valuable insight. So please give them another warm round of applause. Thank you.
Yeah, thank you. Thank you for that. Yeah, that's nice.
This concludes Changhee on AI for Life. This concludes the Global AI Frontier Symposium 2026. On behalf of the organizers, I'd like to extend our sincere appreciation to all of our distinguished speakers, panelists, and participants for being with us today. So we hope today's discussions has provided valuable insight and inspired new ideas that will help shape the future of AI. So thank you once again for being with us. Yeah, we look forward to seeing you again at the next Global AI Frontier Symposium. Thank you.